We're going to have some welcome remarks from Dave Donaldson and Charlie.
Thank you, Madam Chair. I want to welcome everyone to our 75th annual GSMFC meeting and welcome to the beautiful beaches of Alabama. Weather's turned a little cooler than it's not quite beach weather, but it's still a beautiful venue. So, over the past several years, the commission has done these general sessions to talk about a variety of different topics, and including economics, mercury, ROV, oil spill, uh, har- harmful algal blooms, oysters, recreational fisheries, and a variety of other issues. So, in this session, we're going to present the results of several research projects that were funded by the commission through the NERDA restoration money and under the Return 'em Right program. So I will turn it over to Charlie to give us a brief overview, and then we'll get right into the presentation. So thank you.
Yeah, thanks, Dave. Yeah, as Dave said, about 4 years ago, we started the Return 'em Right project with the commission. So that was the main reason why they hired me. So I'm kind of glad to be able to kick off this session today. It's been a really fun project. I think you guys will note during the presentations today the uniqueness of it. It's a little bit outside of the box. It kind of blends the research with data collection that a lot of you guys are helping with, couples with marketing and outreach education, which Nick and Florida Sea Grant have done a really great job of helping out with and leading that side of the project. So it's not your typical restoration project that a lot of us are probably used to, but that's what makes it fun and hopefully a really effective project. So we built some strong partnerships for this program. The core team is NOAA's Restoration Center, as well as a couple other divisions within NOAA, Florida Sea Grant, and then obviously the commission. So today's session is going to highlight some of the work that's led by the commission and a little bit from Florida Sea Grant. And when I say the commission, I don't mean Dave and I mean a lot of this is the work that you guys are helping support. And so I really want to highlight the role that you all have in the research and the data collection and a lot of the outreach education, because without having your support, we would not be able to make this program as successful as it has been so far. So this morning we're going to dive into a little bit of the monitoring and evaluation stuff that the commission has been leading, and then we're going to follow that by some of the work, kind of wrap up the session with what Nick and his team at Florida Sea Grant have been doing to reach out to the angling community and get the work that we've done and the information that we're learning about descending devices and best handling practices and other things in the Gulf out to the anglers. So got a couple things. So we did a booklet. It's got abstracts in here. If you haven't seen it, there should be some around the room. This kind of goes over the presentations that you're going to hear from today and a little bit more detail about the Return 'em Right project. We are recording this session, so I just want everybody to know that. Please turn on your mics when you're talking, and folks in the audience, or there's a few people online as well. We do encourage that you ask questions. We want to engage with you. We want to help make sure that everybody understands Return 'em Right and all the cool stuff that's going on. So if you have questions, please step up to the mic or just jump in at the end of each presentation. We'll have some time to talk through some of that. All right, so let's dive into the session. So thank you all.
We're going to have our first presentation titled Determination of Predation Mortality, Barotrauma Survival, and Emigration Patterns for Catch and Released Red Snapper by Dr. Szedlmayer.
Good morning. I'm happy to be here, and I will say I want to thank the Gulf States Marine Fishery Commission for funding this project. I think we had an enjoyable time doing this project. It was probably one of the most fun projects I've had in my entire career. So in starting in 2021 to 2024, we wanted to compare their survival among release methods at about 20 to 50 meter depths off the coast of Alabama. We wanted to compare 3 different release methods: surface release, where you just unhook the fish and throw it to the side; a drop weight release, that is, we use the sequelizer. There's several drop weight methods. You can use various descender devices. We use the sequelizer in this study. And the cage release. The cage release is not really a practical method for fishermen, but it's our control. Years ago, we found out that when you protect the red snapper against predators, you put them in a cage, you really, really increased your survival. So we compared these 3 methods. We compared the survival, the mortality, and emigration from 2 different approaches. We used conventional tagging. Just put an anchor tag in the apaxal muscle or back muscle below the dorsal fin. Or we also did telemetry tracking. This is where you put a transmitter in the fish and you put receivers out, data loggers that can detect the fish anywhere it goes, and you can determine its mortality, its emigration from the tracking. So 2021 to 2024, we used dart tags. We put them in the apaxal muscle. We selected 12 sites, and this is 12 sites where we could catch enough red snapper and split among the 3 different release methods. So we would attempt between 45 and 60 releases on a particular site. We would have between 15 and 20 drop rate releases, between 15 and 20 cage releases, and 15 to 20 surface releases on each of those 12 sites. The drop weight release, we used the sequelizer. This method can seem a little bit cumbersome, but after you get used to it and you practice it a little bit, you can really get efficient at it, and you can turn this fish around pretty quick and get them back down again. So here's a red snapper released with a sequelizer in 2021. We also put GoPro cameras, and during the second part of the study, we learned that you needed to put a GoPro camera on both the pointing up and pointing down to help you increase your detection of predation. The cage release method, we developed this a number of years ago. This is a stainless steel cage with crab pot, vinyl coated wire on it. The door opens when it hits the bottom. So it protects the fish on all sides except for one. We've actually videotaped fish backing up in the cage as a shark or a dolphin was on the outside of the cage trying to get out, and they would not leave. So they can detect where they are, they can see the predator, and it really increased survival. This is just shows this is about a 15-pound red snapper in the cage. It barely fits. The cage was about 1 meter by 1 meter. And this is what we're trying to protect them against. I want to show this picture because that dolphin would get that snapper if it wasn't in the cage. It's pretty obvious. Okay, so all of this study with the conventional tagging, it's based on recaptures, which we felt was a real advantage. We don't have to make any assumptions about survival. We don't have to make any assumptions about emigration or where the fish went. It's all based on what was recaptured, and it's real simple. Were they cage released, were they surface released, or were they drop weight released? So we had 2 approaches to do the recaptures. We used fish traps, which is a very efficient method of catching red snapper, and I'm really glad that it's totally illegal. When my commercialman first saw it, this is 20 years ago, he says, "Oh my God, I have to get one of those fish traps." I said, "You can't." Hook and line we used, and the Fisher recaptures are hook and line. This is our fish trap. This is a chevron fish trap. It comes from the Caribbean. It's very, very efficient. If you go to Guadalupe Island, the whole island is covered with fish traps. Everywhere you see them, and there's not a single fish on any of the reefs. So that's how efficient they are. We also use telemetry tracking. The fish are released with an external transmitter and a Floyd tag. We use a Nova C V16 transmitters. They're attached with plastic disc and plastic coated wire that's run through the fish, and there's 2 plastic discs on either side of the fish, and it's crimped with stainless steel crimps. Here's a picture of a red snapper with the V16. We were limited to what I call relatively large red snapper when you use this method. So telemetry tracking, we had 6 what we call VPS tracking sites. Each of these sites had 5 receivers, and at each one of these sites we used surface, drop weight, and cage releases with transmitters. We used the standard Vemco receivers. This is our design, our array. That's to north, south, east, and west. There was a receiver that was placed 300 meters away from the center site. The center site was next to the reef. And you can virtually, we get 100% detections within this array. Here's our location off Alabama. Our sites that were sampled, we went all the way out to the edge, about 45 meters. And the X's are where we used telemetry and conventional tags, and the other dots are where we used just conventional tags. This was a particularly good day where we got a lot of recaptures. It's so exciting to get recaptures, you know, and some days are better than others. This was a particularly good day, lots of recaptures. But total to date, 2024, we got 214 recaptures with conventional tags. So results to date up to July 2024, you'll see a column there, attempted releases, for example, with the cage. Right here, 304, and then you see over here, successful releases, that's 235. So we did it 304 times, but it didn't work all the time. Sometimes the fish came back up, sometimes the cage fell on the door, and the fish could not escape. So that's why we only had this number here, this 235, which is the number of successful releases. For the drop weight, 227 total, 227 successful. Surface release, well, you just thrown the fish over the side, so obviously those are all successful. Recaptures, we got 78 recaptures from the cage, 62 recaptures from the drop weight, and 75 from the surface. Pretty even numbers for a total of 215. That's a really, really high number, 215 recaptures out of this total successful releases of 722. That's about 29% of the fish that we released, we recaptured, which is a phenomenal number, even if you're working in a lake somewhere. Okay, what are the crux or the main point of this paper is that we didn't see any difference between the different release methods. The cage release, remember, is our control. We expected the highest release there. This is the drop weight release. It wasn't significantly different from the cage release. This is the sequelizer. So for the depths that we looked at, the drop weight release showed the same. Well, this was the real surpriser. The surface release showed just the same amount, same survival, same recapture. I didn't even want to do surface release. Charlie argued with me, you got to do surface release. Of course, he was right. It turned out, surprise, surprise. Okay, so then we split it up and we looked at by depth. So the top graph up here is the shallow depth. Again, no difference between the different methods. Mid depth, 30 to 32 meters, no difference in the release methods. Deep water, which we call 37 to 37, again, no significant difference. And then we get to what we call the slope edge, 41 to 44 meters, no difference in the 3 methods. There was no interaction effect of depth versus release method. However, there was a significant depth effect. So if you pooled everything and you looked at surface release, shallow water release, mid water release, deep water, and edge, the edge of the slope had much higher mortality than the other 3. These 3, the first 3 were not significantly different, but the edge showed much higher predation or mortality. And this is not surprising. The deeper you get, the greater the barotrauma effect. And beyond this point, I think you would get really, really high. If you started releasing it at 100 meters or 150 meters, I think your survival is going to go down really, really low. But there's the trend. Get to the edge, and all of a sudden, you're getting lower survival. So for the telemetry work started in 2022 to 2024. We released 67 transmitter tagged red snapper on 6 different sites. 23 were cage release, 19 were surface release, and 25 were drop weight release. We get data from the receivers. We calculate the position. We can get positions on these fish every 10 minutes, 24 hours a day, 7 days a week. You can follow them around. You can see them immigrate. You can see them die. So telemetry is really exciting. The limiting factor with telemetry, though, is always sample size. You always have, transmitters are $300 each. Here are the 6 sites where we released transmitter tag red snapper. Army tank, we released 10 fish. We tracked them for 172 days. Natural rock reef, this is about 30 miles south of Dauphin Island. We released 13 metal cages. These are what we call chicken coops. 10. A pipeline, this really surprised me. We only were able to catch 1 fish on this particular pipeline. That for years we caught fish. This is part of Darren's dissertation, same pipeline. Metal cage, another chicken coop, and a metal cage, 11. So fish were tracked from 1 to 224 days. We weren't interested in long-term tracking on this study. We were really only interested in the first 2 weeks. Did it survive or not? So we got some good data with the telemetry based on this short-term tracking. So how do you tell what happens with a fish? By looking at the transmitter tracking data. Well, this is a site. This is, again, a chicken coop. I labeled Sims 5 because David Sims, a commercial fisherman, gave me the site many, many years ago. He forgot about it. You can see, let me back up. Okay, this is what we call a resident fish. This fish was tracked for 74 days from 3 March to 16 April, and all the data points are around the reef. And this fish, we pulled the receivers, it was still there. So we call it a resident fish. This is what we call a resident fish. Here's an interesting track on a fish that was tagged on an Army tank. And it was only tracked for 8 days. But it first went to this Army tank, and a few days later, you can track it, you can follow these dots, and it swam over to the second Army tank that was 300 meters away. And then on the 24th of April, at 2100 hours, this fish emigrated away from this site. So even though this fish was only tracked for 8 days, it ended up on 2 different Army tanks, and then we tracked it away from the reef, and we considered this a survivor. So it's only tracked for 8 days, but this fish was alive and well when it left. So we considered for this project a survival. Okay, what about mortality? This is a track that we considered and identified as a predation mortality. Immediately after it was released here, it started at 1500. It started tracking these wide, long distance movements, and 3 hours later emigrates away from the reef. We consider this a shark predation. Why do we think it's a shark predation? Here's a shark tracking pattern. This is a sandbar shark that we tracked back in 2015 on a very similar site. You can see the receivers 300 meters out. And starting on 1525, this shark's moving around, follow it all the way around, and by 7 o'clock the next morning, it's gone. So this matched what we considered a predation, and we've had several of these. We tracked several sharks. This shark pattern matched what we call a predation pattern. So what are the total results for the telemetry work? Well, all of a sudden we see a significant difference. Here's the cage release. We got 100% survival on all fish that were released with transmitters in the cage. Well, this is what we nearly expected. The drop release showed about 84% survival, and of course, the surface release showed much, much lower survivals, and it was significantly different. So he said, okay, well, maybe surface release doesn't work like it did with the conventional tags. However, we think there's a complicating factor here with the surface release. This guy has a great big transmitter on his back. And when you throw it in the water and you see it struggling and it's trying to move and that we feel that transmitter attachment is what caused that surface mortality. It wasn't due to throwing the fish over the surface. So I think there's a complicating factor in this data. Okay, so what about transmitters? One of the big things about transmitters is, do they stay attached? You're putting these transmitters on the outside. My entire career, I've always put internal transmitters. I was asked to put them on the outside. Do they stay on? How do you attach them? Very little data on whether they stay attached or not. So we have a seawater system, it's a 4,000 gallon seawater system. We bring them back into the lab and we wanted to see, did the transmitter stay on the fish? Did it kill the fish? So here's a couple red snapper with tags. I don't know if you can see it or not, but there's a transmitter on the side of the fish and there's a conventional tag. So we held these fish in the lab for a short time period. Remember, we only needed 2 weeks for that transmitter to stay on the fish. And you can see the tag date. This is this year, April 24, May 24. The size, they're fairly large fish. This is total length. These mortalities in this column here, some of them are actual mortalities, but some are when we just stopped the experiment. So we've had them in the lab long enough. We had the fish in the lab for 39 days. Let's euthanize them and stop the experiment. So all these fish lasted long enough to validate our use of transmitters offshore in red snapper. And the important point is they all stayed firmly attached. We had no tag loss on any of the fish. And also in our observations, when we're watching these fish, they would come up and feed out of your hands. It didn't seem to affect their feeding at all. So we felt that they were doing well. Again, we had large red snapper. If you put these transmitters on small red snapper, I think you're going to have a problem. So the lab transmitter retention study, all transmitters remained firmly attached. We had no detectable effects on feeding. However, here's a surprise that we didn't consider. That last thing, external attachment of transmitters caused abrasion. And we don't think that transmitter attachment on the outside of a red snapper is a suitable method. And I'll show you. Here's a red snapper from the lab, the transmitter on the side. And here's the abrasion. This was unexpected. So unless you get recaptures and can see what a transmitter looks like, when you put it on the side of the fish, you won't see this. This is a lab study. This happened to all the red snapper that we had in the lab. They got these severe ulcers and abrasions. So final conclusions of this study, there was little difference in survival among the release methods. And one of the things I want to point out is fisher behavior did not affect the results. There was no way that a fisherman could know that that fish was released with a cage or released drop weight or it was a surface release. They just reported it. So there's no way that they could bias their results. Our sample sizes were robust. We had 722 tagged fish, 215 recaptures. Here's another important point that I want to point out. Fish handling time will increase survival. When we brought the fish to the surface, we timed it. We sat there with a stopwatch and we tried to get every fish back in the water in under about 3 or 4 minutes. You don't see this with fishermen. They're taking pictures, they're holding it up, they're messing around with the hook. The key here is to communicate to the fishermen, get it back in the water as fast as you can, and you're going to increase your survival. Another point that I like to, there's a misconception about fish retrieval time. A lot of people will communicate, I'm going to bring it up slow and it's going to better equalize and it's going to do better with barotraumic stress. That's not the case. There's a physicalistic fish. This guy has a closed swim bladder. It cannot equilibrate until about 48 hours. So you can't bring the fish up slower. You bring it up fast. Get it off the hook. Get it back in the water. So red snapper cannot better equalize with slow retrieval. Increased depth will reduce survival. So as you get deeper, you get beyond the edge of the shelf there, you're going to have problems with survival no matter what method you use. So that increased fish, getting them up, get them out is really, really important point. So for the telemetry, there was a significant difference in survival among the three methods, with surface release showing the lowest survival. Well, this is expected. I thought this before we even started the study. The surprise was when we got survival from the surface releases. Low surface release survival, though, in this telemetry was likely due to the transmitter attachment and not the release method. Predation caused a reduced survival based on tracking patterns. We looked at the tracking patterns when we said, oh, this fish may have died, and you saw a tracking pattern, it confirmed it. And last point is that predation effect was also supported by the 100% survival of the cage release. So anything that we put out with a transmitter and we put the cage around it, it was protected and it wasn't eaten. So that's the end of my PowerPoint. I want to thank Shay Holmberg, Dan Ellard, Jared Burge, Rachel Nichols, Olivia Eisenbach, and Jeremy Arndt, who all helped out with this project. And then I have some real quick, short videos that I want to show. Can we have video one? Okay, this is Sequelizer. That's a shark. And what you might expect, it's like a fishing lure. The shark ate the fish off the Sequelizer. All right, next video. I want to show the cage here, and you'll see a sandbar shark approaching. And my point here is the shark did not get the red snapper in the cage. He tried. There. No. Well, the snapper made it. Next. Okay, this is hard to see. You got to look close. Look on the left, and you'll see a dark shadow. This is a cage that fell on the door, so the snapper couldn't get out. You see the dark shadow? Anybody guess what it is? Yes, whoever said grouper. It's a Goliath grouper, about 400 pounds. Watch him bite the cage. Let's see it. Come on. All right. He didn't get snapper. Probably would have got it if the cage was open. Okay, this is same Sequelizer release, and Flipper decides he's going to have a meal. Now, I really think that the dolphins have learned. When we first started cage release, they didn't know what a cage was. And then this happens. This is my last video. It's hard to see. Well, what's happening is the dolphin is slamming the cage with his tail. And he does this over and over and over again for about 10 minutes. And then at one point, he comes in and gets the snapper. So there he goes. So they've learned that what a cage is. They're smart. Anyway, that's my presentation. Questions? Yes, Rick.
Thank you for your presentation. That was very interesting. Were you able to look at any correlations between water temperature and survivability, or was most of the work done in the early part of the season when the water temperatures were cooler?
We did not see any relationship with temperature. The surface sometimes warmed up, but all of our studies, the temperature was always cold on the bottom. I can attest to that. Diving down in the middle of summer and it's 72 degrees at 80 feet. So We never really had a mix of water to surface temperature, but we, it, I would definitely say there is an effect of surface temperature. I mean, I've seen it over the years, but I don't have any data in this study.
Thank you. Thanks, Steve. That was brought me back in time.
Yep.
It's like
Still some of the same sites that you sampled.
Yeah, it was awesome. That was really good stuff, and I always wanted to do that kind of stuff when we were there, so that was interesting. I do have a few questions, but I know so much about what you do, I don't want to ask everything. But I did want to ask about the seasonal effects of water temperature. In the very beginning, you had a table that said successful release, right?
Yes.
Did that include successful release with a predation? Is that a successful release, or because it was like?
Yes.
Okay.
Yeah.
Yeah. So that's just the release.
The unsuccessful releases
the cage
were
one.
fishes that we did not release. We put them in the water, we put them in the cage, and they came back up in the cage.
That's why it was 100% for the drops. With the conventional tags, you had a lower recapture rate on the edge, the shelf edge. Is there any possibility that the lower surface recapture, or the lower recaptures on the edge were due to just not fishing out there as much, or is that, there's not as, the chance of recaptures are lower?
I would say, my feeling is no. There's a lot of fishing pressure going on out there. It's phenomenal. We had one site that we thought was far away from everyone. It was a private site, and we had 5 charter boats returning fish from that site. And so the distance is no longer a limit today. When you were working, yes, distance was a limit because they didn't have all the go-fast boats. Now they're out there in an hour.
There's also a lot more predation now than when I was there, like, was it how long ago?
Yeah.
A while ago. But what do you think about the predation increases since over time?
I can't comment on whether predation has increased over time. We had predation back in 2011, 2012 that drove me nuts, and for the 15 years prior to that, we did not. But I don't have any information on that.
But yeah, we didn't have that. I mean, we had some sharks, but not like what you see now, I think. But thank you.
I was curious if you had, you kind of hypothesized that the lower survival for surface release for the telemetry was due to the tag attachment. Could it potentially have been also due to the fact that it's larger individuals that are more stressed from a longer fight time that require more energy to swim back down to the surface than compared to tag attachment?
It could be. I don't know the answer, Nick. It could be that the bigger fish get more exhausted, and so when you release them with a transmitter on them, they're not doing the same thing as a 17-inch snapper released with just a tag. Yes, it could be.
What we see a lot on camera is that descending the bigger fish, they actually like tumble and take time to reorient even after descending, versus a lot of the smaller ones will pop off and like swim right away. So it seems that sometimes those bigger fish are just more tired from the fight. So maybe there's something there too, but I'm sure you have links for everything. Can maybe look into that.
But I agree.
Yeah, Kevin from the audience. And if anybody in the audience has questions, just feel free to raise your hand. You can step up to the mic.
Thank you, Dr. Szedlmayer. Good presentation. I was just wondering, did you take any dissolved oxygen readings at each of the sites?
Yes, we did. We took dissolved oxygen at every site, every time we were out there with a very accurate YSI, EXO, and we never had any limits on oxygen. It was always very high, I'd say anything above 4 to saturation. We never saw any limits where it was getting down to 2.5 or 1.5.
I was just curious about your observation with the one site, the pipeline site, and then just carry over from Nick's comment regarding size is that might have an impact. So
Yeah, I mean, over the years, we have measured 0 dissolved oxygen out there, and there were no fish on a reef, so.
Any other questions? All right, thanks, Steve. I still can't believe I don't get any credit, all the trips I came on with you. Just kidding.
Thank you, Charlie, for going out with us and helping.
Yeah, I'm looking forward to more now that you've got a new boat. And then there's a couple folks that are staying. I know the seating's tight in here, so if you have it in you to scoot closer to your neighbor and maybe open up a few seats for some folks to sit down if they'd like, that'd be great. Thank you.
Okay, we're gonna have our next presentation. Do descender devices increase opportunities for depredation? A Gulf-wide examination of descender device depredation rates and depredating species by Amanda Jargowsky.
Good morning. My name is Amanda Jargowsky. I'm here representing Mississippi State University and a team of scientists across the Gulf of Mexico states. I'm pleased to present to you Depredation on Descender Devices, a Gulf-wide investigation. Before I begin, I'd like to acknowledge my co-authors, Alina Anderson, Danielle Mackery, Matthew Jargowsky, Angela Collins, Matthew Strike, Nicholas Haddad, Michael Sipos, and Marcus Dryman. Increasing post-release survival of discarded fishes is a critical challenge to effective fisheries conservation and management. Among reef fishes, this challenge is further complicated by pressure-related injuries collectively known as barotrauma. Left untreated, these injuries are often fatal. Tactics to mitigate the adverse effects of barotrauma, including venting and descending, have been well described and readily adopted by regulatory agencies as best practices. In the Gulf of Mexico, the Descend Act, effective January 2022, requires fishermen to have a venting tool or descender device rigged and ready to use when fishing for reef fishes. However, simply requiring possession of venting tools or descender devices does not guarantee their use. Consequently, any potential benefits resulting from the Descend Act rely completely on anglers embracing the use of venting tools or descender devices. So that will only happen if anglers truly believe that these tools increase post-release survival. Depredation, defined as the partial or complete removal of a captured species by a non-target species, is consistently discussed among anglers and regulatory agencies as an escalating problem in need of mitigation. Interestingly, angler concerns regarding depredation not only apply to fishes being caught, in other words, ascending, but to fishes being released, in other words, descending as well. Anglers have specifically stated that using descender devices to release fishes simply provides additional chances for depredation. For example, during a 2019 Gulf Council meeting, Charter for Hire captains stated, "I have used the descending device with the FWC projects and I'm not crazy about it and I'm not for it being mandated. Right at this particular time, if I put a descending device on my boat, I'm going to have a 55-gallon drum of them because everything we descend down, that thing is going to be eaten off by a shark." As far as the descending devices, unless you're going to give them to us by the barrels, we're not going to be able to keep up with them. And the descending device, like everybody else has been saying, it's going to take a pile of them, and that's all I can say. So if resource managers are to promote descender devices as best practices, they must proactively address angler concerns about depredation of fishes during descent. In 2019, we published a preliminary opportunistic comparison of 2 red snapper camera datasets from the Alabama Artificial Reef Zone to investigate the frequency of depredation on descender devices in this region. One dataset was from a vertical longline study, and the other was from a mark recapture or hook and line study. The data sets span 2016 to 2018. This map shows the results of the comparison. The Alabama Artificial Reef Zone is outlined in black. The ascending fish are shown on the left-hand panel and descending fish on the right. In both panels, red circles indicate depredation events, while black X symbols indicate ascents and descents with no depredation. GoPro video footage of ascending fish, a sample size of 1,483, showed 69 depredation events, while footage of descending fish, a sample size of 1,096, showed 0 depredation events. Although this study provided basic information about depredation rates on descender devices, this small study area, single species focus, and fishery independent approach limit the applicability of the conclusions. Therefore, we sought to investigate depredation rates on descending fishes across the U.S. Gulf of Mexico and identify species responsible for depredation. First, we generated a written step-by-step field data collection protocol. Then, using the written protocol, we then created a 2-minute whiteboard-style protocol video that briefly summarized the topic of interest and reviewed the data collection protocols. So I'd like to play that video for you now.
Depredation is the partial or complete removal of a captured species by a predator. Some anglers are concerned that descender devices, like sequelizers, provide easy opportunities for depredation. Our objective is to use GoFish cams to document depredation rates on descending reef fish and identify species responsible for depredation. You will receive $100 per trip for up to 20 trips throughout 2022, but you must descend at least 5 fish per trip. We appreciate your help. This video will summarize the data collection protocol. For more details, please refer to the printed protocol in your startup box. Before fishing, ensure your GoFish cam is fully charged and contains an SD card with less than 7 hours of footage. Attach your GoFish cam to a fishing rod and attach the provided monofilament rigging to the GoFish cam. Clip the sequelizer to the middle loop and add some weight to the bottom loop. Then, navigate to a fishing spot between 60 and 300 feet. If you catch any non-target or undersized fish that you plan to release, complete the following steps for each fish, even if it exhibits no signs of barotrauma. 1. Set the sequelizer to the appropriate depth setting and attach the appropriate weights to the line. More is better. 2. Turn on the GoFish cam and firmly press the red record button, but do not hold down the record button. 3. Attach the fish to the sequelizer, descend the fish, and retrieve your gear. If you have additional fish to descend, repeat step 3. Otherwise, stop recording, turn off the GoFish cam, and fill out the data sheet. After fishing, soak the GoFish cam in fresh water and dry it thoroughly. Finally, be sure to charge it up so you're ready for your next trip. Good luck out there.
As shown in the video, 2 types of data were to be collected for the project. Video footage of fish descents on sequelizers, which would be recorded using downward-facing GoFish cams, and fishing site and fish descent information, which would be written on data sheets. The data sheets included many fields, but the ones most relevant to this presentation are general fishing location, depredation on ascent, surface, predator identity and quantity, and species released. Using trial and error, we developed a setup to prevent the loss of the GoFish cam if the sequelizer was snagged on something or taken during a depredation event. The top of the GoFish cam was attached to the main line. Then a snap swivel connected the bottom of the GoFish cam to the rigging, which included the sequelizer and weight. Importantly, the rigging monofilament was lighter test compared to the mainline monofilament, so that everything beneath the GoFish cam, in other words, everything in the rigging photo, could be taken, but the camera would hopefully remain attached. For this project, we decided to involve the charter for hire fishing sector as data collection partners. We recruited, trained, and incentivized 30 skilled charter for hire captains across the Gulf of Mexico to collect data during their typical charter fishing trips. To train the captains, we met with the captains and or their deckhands in person or via video conferencing to explain the project's purpose and protocols. The captains were incentivized $100 per trip for up to 20 trips. As shown in the photo, we provided all of the data collection supplies, including sequelizers, GoFish cams, rigging, memory cards, data sheets, clipboards, pencils, and prepaid envelopes to the captains in conveniently packaged startup boxes. As early as the training phase, we experienced issues with captain participation. We had trouble even training all 30 of the captains on the data collection protocol, and only 7 captains ended up collecting data for the project. This can be attributed to 3 main issues. The value of the incentives was too low, and correspondingly, the number of captains was too high. And the time and effort required of the captains and their deckhands, both on and off the water, was too demanding. These issues represent important lessons learned from this project that we will be sure to incorporate into future project plans. So to supplement the data collected by the captains, we, the project team, hopped aboard fishing charters and collected data ourselves, particularly in locations where data were lacking. The captains and project teams submitted video footage and data sheets to the Mississippi State University team members who analyzed the videos. This entailed assigning water clarity and vision field scores, logging predator presence and identity from the videos, and determining the fate of each descended fish. Descents that lacked video footage or had poor water clarity or vision field scores were removed from further analysis. Here's a video that shows 2 examples of poor scores. In the first clip, the descent is occurring in such deep, dark water that it's impossible to observe the release of the fish from the device. In the second clip, we can see everything very clearly, but unfortunately the fish ends up being released outside of the vision field of the camera. From March 2022 to March 2024, 987 descents were successfully recorded off Texas, Louisiana, Alabama, and Florida. As shown in the map, primary sites of descents included waters offshore of Corpus Christi and Galveston, Texas, Venice, Louisiana, Dolphin Island and Orange Beach, Alabama, Destin, Florida, and Crystal River to Marco Island, Florida. The size of each red circle corresponds to the number of descents at that particular location. Approximately half of the descents were recorded by the charter for hire captains, and half were recorded by the project team, highlighting the success of the hybrid approach. Most of the descended fishes, representing 20 species in total, were red snapper, 684 or 69%, or red grouper, 197 or 20%. The remainder included mostly reef fishes such as other snappers and groupers, jacks, and triggerfish. Here's a video clip of a red grouper descent from Florida. A total of 157 descents occurred at fishing sites where at least 1 and up to 10 fishes were depredated on ascent. For 114 of all descents, predators were present at the surface. These included sharks, 17, or dolphins, 97. For 44 of all descents, predators were apparent in the video footage. These included sharks, 34, dolphins, 7, or Goliath grouper, 3. Examples are shown in these video screenshots. Overall, the video footage indicates that depredation of reef fishes returning to depth on descender devices is exceedingly rare. In just 3 cases, all off the coast of Louisiana, a shark depredated a descending red snapper. In 2 of those cases, June 15th, 2022, and the first of 2 on March 14th, 2024, the depredator was a black-tipped shark. In the third case, the second of 2 on March 14th, 2024, we were unable to identify the shark to species. For all 3 depredation events, no predators were seen at the surface. For the June 15th, 2022 depredation, no depredation occurred on ascending fishes at that fishing site. However, for the March 14th, 2024 depredations, 1 fish was depredated on ascent at that fishing site. This video will show each of the depredation events in sequence. The results of this study contribute to the growing body of depredation research in the Gulf of Mexico and suggest that depredation, though a significant problem for ascending fishes, is essentially a non-issue for reef fishes on descender devices. The overall depredation rate was less than 1%, and the depredation rate when fishes were depredated on ascent was still less than 2%. Thus, Gulf of Mexico anglers should embrace the use of descender devices as effective tools for mitigating barotrauma in the reef fish fishery. In addition to the more typical fish descent scenarios, we observed some interesting behaviors in some of the videos, and this video shows the most notable of those behaviors. In the first clip, immediately following a successful red grouper release, a cockerinid shark persistently pursues and attacks the sequelizer on ascent. In this next clip, we see a dolphin investigating a descending red grouper. It does not attempt to depredate the fish, but as soon as the fish is released from the sequelizer, the dolphin quickly follows the fish out of frame. And lastly, on one occasion, the Go Fish cam fell off the rigging, and a Goliath grouper decided to take a rest on top of the camera. But impressively, the captain was able to snag and retrieve the camera, and all was well. So now that we've concluded the data collection and analysis portions of the project, we're working on a second whiteboard-style video that will explain the results and their implications to stakeholders. The video will include information about depredation rates on descender devices and the species responsible. We'll use the video in communication efforts to encourage stakeholder adoption of descender devices. Specifically, we will share the video on social media with management agencies, including Gulf States Commission, the Council, NOAA Fisheries, and state-level agencies, industry groups, industry groups, NGOs, and recreational fishing groups. We also look forward to working with Nick and the Return 'em Right program to distribute our results as broadly as possible. This project was funded by the Gulf States Marine Fisheries Commission, and we're grateful to the following charter for hire captains for their participation in the project. Brad Gorst, Brett Falterman, Clarence Fleck, Gary Bryant, John Green, Troy Frady, and Zachary Tapp. Well, there's one more slide, but it won't advance. So thanks for your attention. Oh, there it goes. And at your time, I'm happy to answer any questions.
Amanda, I have one question for you.
Yes.
Did you lose any of your camera gears and the sequelizers? Because in the very beginning of your presentation, that was a major criticism from the fleet. They said they were going to need 55-gallon jugs of them. Yeah.
We did not lose any due to depredation. Like there was the one camera that just fell off, but no, none to depredation.
Great presentations. I have two quick questions. One for Steve. Did you do any venting of your surface release, or they were just caught and released?
No, no venting.
Okay. And then you mentioned, Amanda, that you had 30 captains that you sent packages to. So did they volunteer and then fail to participate, or you had just how did that? It just seems like a strange number that only 7 participated after 30 received packages.
We reached out to captains and to gauge their interest and came up with a list of 30 folks who said they were interested, and so we proceeded with that list. But it just ended up being too much work on top of everything else that they've got to do every day.
It's just a shame. That was a lot of lost opportunity. But Steve, one other question: when you released on the surface, were there ever dolphins present when you made the releases?
All the time.
Thanks.
Amanda, I have a question.
Go ahead, Steve.
You based the conclusion that predation did not occur on the sequelizer based on 2 or 3 seconds of video in a very limited spatial area that the video was able to record. What do you think about predation occurring 10 feet away, 15 feet away, or the next day, or occurring in the other direction where the fish falls off and goes up and you missed it because the camera was pointing down? We did observe this. That's why we ended up putting 2 cameras pointing up and down, because we found out we were missing predation events that were occurring above the sequelizer. So is that possible?
Sure, it's possible. We just, if this fish was successfully, if it came off of the sequelizer, if nothing took it off of the sequelizer, we did call that, a successful release without depredation. But, a bigger vision field, more cameras would have definitely, given a greater picture.
Yes, I've got one for both of y'all, and even if Eric's got some insight on it. But, the whole goal of the Return 'em Right project and everything else seems to be creating, some actionable messaging or practices that can be adopted by the fleet to ensure some level of conservation measure can be applied. So it seems like our messaging has always been to anglers that if you're within 150 feet of water, the best practice is just to try to get the fish back in the water, similar to what Dr. Szedlmayer stated. And while
This meeting is being recorded and summarized.
Perfect. And while I do think the center devices certainly can be adopted, I wonder if based on the results that are observed, the messaging starts to tend toward, since most of these anglers that are going out are only taking 1 or 2 trips, right? They're not necessarily avid. The bulk of the fleet is only a couple times. Is it get the fish back in the water as soon as you can, and if predators are around, then the situation arises for descent of descender devices, or, you know, leaning into that presentation you just provided, would you think that you encourage descender device use as much as possible?
That's a difficult question to answer.
Absolutely.
Yeah, for me, every factor has to go in, as is written in the final report that Charlie put out, which I thought really addressed that. What do you do under various scenarios? If you're in the middle of winter time and the water temperature is 62 degrees and everything is the fish are active and alive, you know, I don't think a descender device would be needed. But you said 150 feet, or did you say 150 meters?
Within 150 feet.
Okay.
Yeah.
Yeah. I mean, I watched fish go down quickly, but the key for us was how fast can you get the fish up, and how fast can you get it off the hook. And I tell people, don't even bring it in the boat. Use a dehooker, and just as soon as it comes to the surface, dehook it. If you're going to release it, don't even bring it in the boat. Don't touch it. Back in the water.
Because with ours, I mean, you're talking about 60 to 70% of the fleet taking upwards of 2 trips a year, right? So they're not necessarily doing it every day. And it takes a little bit of practice to get handy with the descender device and handling the fish on board. Our concern was always you're increasing handling time because they're fumbling around with the fish on the deck or whatever else, and potentially impacting survival.
Yeah, like I said, Charlie covered this scenario, what you're asking, and it's a complicated question. Temperature, time of year, you know, how fast did the fish come in?
Just to speak on that point a little bit, typically those anglers that are only fishing 2 times a year aren't going to be the quickest ones to dehook a fish and get it back in the water no matter what. And whether if you're promoting to get fish back in the water quickly, but you're kind of forgetting about also teaching descending, you can't descend a fish if you don't have it on the boat and you don't know how to use it. So even I've got to go out on the boat with Steve, even at 100 feet of water, some of those surface release fish floated off. So at that point, let's say you're one of those anglers that fishes 2 times a year, do you just watch it float off and die, or do you have a descending device rigged and ready and throw the fish on the descender?
Yeah.
So I don't think the messaging is to use it on every single fish, but, you know, have situational awareness. But whether, if you don't know what it is, you don't know how to use it, it's not on your boat, you have no option but to let that fish float off and die. And I think that's the more important message here, is that you don't need to use it every time, but you need to have it on the boat, because there will be a time you will need it if you fish offshore in deep water.
Be prepared to use it.
Yeah.
Just one more comment, and Nick was on the boat this day, and he videotaped this, and we threw a fish over surface release, and we thought he was doing great. And he slowly swam down, got down to about 30 feet, and we saw a big old sandbar come up and slowly eat him.
Oh,
So,
yeah.
Also, one more comment to address Scott's concern about the video with the captains. I've used a lot of the different video cameras, and Go Fish cameras became really popular with anglers, especially when trolling, so you could run the footage continuously. But I don't think they work quite as intended for having to unscrew the cap, click the button, and actually see if it's recording, versus like a GoPro, you just press the button in the waterproof case. So it's a lot more time consuming in between drops compared to some other camera. So I think some of the issues and some of the additional time constraints might have come from that.
Yeah, I just have a couple comments and maybe a question as well. I guess first, what Steve was referring to is the best practices manual that we published earlier on, and so there's a lot of information in there, kind of getting to some of Trevor's questions about different scenarios and situations where certain best handling practices, including descending, venting, surface release, are applicable. And so I think what Nick's point was is that we want to make sure that anglers are aware of all of the options that they have, so they can make the decision on when it's best to use each one in whatever scenario they find themselves in. And then Chris, your question about loss of gear. I know Nick, was it like 30-something thousand devices that we've sent out so far? And Nick's gotten a lot of feedback from the angling community that have been using them. And I think it's like just very few instances of people reaching out saying, hey, I lost my device to a shark or something. Out of all those 30,000, I mean, we could probably count on two hands how many reports back. I'm sure it's happening maybe a little bit more often than we're being made aware of, but I just think it's not a very common occurrence. So, having buckets and buckets of descending devices it's kind of a exaggeration, I think.
Also, to add to that, I've gone through so many venting tools that the commercially available venting tools don't last that long either. So, just something to remember there, and that's part of the reason a lot of people use knives, fillet knives, and bait knives to vent fish, because for a long time, all the commercial available venting tools seem to break within a few uses. So.
And then I guess just one more thing. So like Steve's presentation, I think we're showing videos of descending device depredation events, and then Amanda's kind of painting a little bit of a different picture. So I know Steve, you didn't exactly have any conclusions directly addressing depredation, so I don't know if it's contrasting or contrary evidence, but I mean, we acknowledge that it's happening. I think being out on the trips with you, one thing that stood out to me, and kind of one of the points that Amanda made in her presentation, is that I think it happens a lot more frequently on the ascents versus the descents. And so a lot of captains and anglers are maybe misconstruing depredation as something that they're seeing it all the time when they're catching fish, but it may not necessarily be happening as often when we're descending fish. And so there's kind of they're applying that same thing that they're seeing on ascents to what might happen would they use a descending device. And so I think, the point that we need to think about here, and maybe Erik will talk a little bit about it in his presentation coming up later, is that maybe it's not happening as frequently as we think it may. And just trying to break down that barrier of people not using them just because they don't think they're going to work when they haven't tried them. And a lot of the evidence we're seeing is that maybe it's not happening as commonly as we're. And we also have videos of fish being descended past predators pretty often too. So there's a lot of evidence showing descending devices dropping these fish down so quickly, and the predators are there in the area, and they're not even really making any sort of acknowledgement of these fish. They're just going right past them to the bottom. So.
Last comment from me here, but that was interesting, Amanda, about the shark chasing the descending device up, because we recently got an email from a participant that lost his gear as he was pulling it up out of the water, the empty descending device. It was about to get to the surface, and a shark ate it just below the boat with nothing on the device. So it's almost as if maybe sharks are learning to follow things upwards, just like when they're following a fish that's fighting upwards. Or being reeled up, so that kind of relates to the ascent problem potentially being, a cue to sharks to follow things going up. I'm not sure what's going on there, but pretty interesting.
Yeah, I would say, we agree definitely based on that preliminary study that kind of led to this one. There does seem to be a big difference between the ascent and the descent, and the anglers can't see what's happening on the descents anyway. So if it's like Charlie said, if they're assuming that what happens on ascent is also happening on descent, that might be a pretty big leap.
Any other questions or comments before we move on to the next presentation?
Okay, we'll have our next presentation, depredation rates and release Mortality of red snapper, gray triggerfish, and greater amberjack released using fish descending devices by Erik.
Hi, everybody. Just a little bit longer and everybody can go eat lunch. But I'm just going to take the liberty of changing the title just a little bit because I didn't want to set up any false expectations. So it's more of immediate mortality, immediate depredation, as Steve had kind of pointed out before with cameras. We can't get that long-term look, but we can certainly see what happens immediately upon release. So moving forward, the reason that we're all here is because of the Descend Act in 2020, we're requiring a venting tool or descender device be mandatory on the boat, and that device choice is left up to the angler. And the goal of that is to minimize post-release mortality, of course. And what we wanted to find out is what devices are the most effective and what's easiest for the angler, right? And that might be species specific, you know, considering the ease of use for the angler, or condition specific. So we wanted to test the biological effectiveness of these fish descender devices and the rate of immediate post-release depredation from these fish descender devices. And we wanted to identify the effectiveness of the different fish descending devices as well. Also, like I said, angler preference for a device type. So we started out with a capture. So we're looking at attributes, predictor variables such as capture depth, fight time, length, and barotrauma assessment. The way we did barotrauma assessment is same methods used by Matt Campbell in the past, and his crew. We had a good response would be 1, a bad response would be 0. So it's a little different between barotrauma symptoms and the stress reflex test. So for example, if you have stomach aversion, that'd be bad. So that'd be a 0. If you did have a gag reflex test, or a gag reflex, that would be actually good. So that would be a score of 1. And then you take all the sum of the responses over the total possible, and 1 minus that would equal your barotrauma score. Higher barotrauma score would equal worse condition of the fish. All right, so we use 3 different devices as I described earlier. We have the lip grip device that we use as sequelizer, the inverted hook device, which is a see you later, and then the fish elevator, which is basically a crab ring turned upside down, weighted by a chain around the ring, right? And we'll see a video of that later. But here's kind of the rigging of this. So we have a fin to keep the GoPro steady so we don't get dizzy and seasick just watching the video. We've got a downward and an upward facing camera. And then we've also got the fish descender device on the rigging. This is a lip grip example right here. The fish elevator was a little bit different. You're going to have the fish elevator below the whole camera rigging. All right, so here's some of our response variables. So we're looking at predator presence absence. We're also looking at predator species and count, but mainly we're looking at the interaction of the predator with the released fish, depredation, possible predation, and then we also want to look at the post-release behavior using kind of a consolidated CMAP release codes. So is it a strong swim? Number 2 is kind of a sluggish or kind of impaired swim, and then 3 is just total loss of equilibrium and just kind of drifting. All right, so here's an example of a fish elevator descent. Joe, if you could play this and then maybe skip to like 2/3 way through the video. Oh, no, it's not going to play. No, it's not going. Well, it worked before when we put it on the computer. But anyway, so basically what's happening is, oh, here we go. Here we go. Perfect. And then hit play. There we go. So you can see as it descends, it's kind of the light penetration is not great, but you can kind of see this fish just kind of drift down out of the fish elevator. That would be a release code 3. And I also wanted to show this video just to kind of illustrate that beyond a certain depth, Although it was relatively clear in the beginning of the video, as we got deeper, the light penetration due to kind of some turbidity issues in Louisiana makes it a little difficult beyond 200 feet to really see what's going on. So we have limited sample size beyond 200 feet, which we'll talk about a little later on. All right, so another component to this was logistical effectiveness, which we wanted to get angler preference for what they would like. We still have a lot of feedback that we have to obtain, partnered with our outreach section of LDWF. So we're not really going to be presenting results on that today, but more of a general overview. All right, so here's some results on the different descender devices that we ourselves put in the water. So we did have a number of videos, you know, I think Steve kind of hit on this, that were not usable. So as far as analysis goes, we weren't able to use everything. That kind of comes into things like turbidity or not being descended correctly, and we'll get into more of that later on, especially with the fish elevator. Impairment was just those release code 2s and above, so basically like a sluggish swim. So there was a lot of fish that were impaired from the initial barotrauma. But then you had depredation or predation and very low numbers, even when we went to the likely column, which would be more like a shark or some other predator kind of mouthing the fish, but we didn't actually see it consume the fish. So we still rated that a likely predation, right? Predator interaction, we had to kind of create a new classification, predator interaction, and reread the videos because we observed so little predation or depredation that we wanted to see, all right, how often are they swimming at the fish aggressively, making some kind of aggressive move towards the fish, and then just can't really decide whether to eat it or not. So that was more of our predator interaction category. And a negative result was just any kind of predation or release code 3, or sometimes it was categorized as both, because, you know, a loss of equilibrium in the fish, sometimes that predator would come and gobble it up. So you have a release code 3 and predation observed in both cases. So these were the just total negative results, either release code 3 or predation observed. And then you have the number of predators around each species descended. So for greater amberjack, of course, we didn't really count amberjack because we didn't really take into account the size of the released amberjack versus the amberjack we saw around the released amberjack. So we just put NA there. But around great triggerfish, you had 32 amberjack. When a great triggerfish was descending, and then about 122 amberjack around the total around all of our red snapper descents. And you can see the sharks and barracuda and cobia, but that was pretty much all the predators that we saw. We didn't really see dolphins, which might be due to our sample size or just a Louisiana effect. So we did have predators present for 34% of these releases, so they were there. It's just that the predation, like Charlie said, a lot of times you would see our drops just go through a batch of predators, and then, you know, they wouldn't follow. All right, so we talked about that release code 3, that's loss of equilibrium, just like basically our worst release code. AJ, we saw none of that. And great triggerfish, we had about 5 of those cases. And then you can see a majority of those cases were due to the lip grip. So E for the device was fish elevator, G is lip grip, which is the sequelizer, and H is the inverted hook, which is the sealator, right? And for great triggerfish, the highest proportion of release code 3 was lip grip, same for red snapper. All right, so we did some logistic regression. We chose the attributes for the logistic regression through a stepwise regression attribute selection based on the lowest AIC value. The AUC reported here, if y'all aren't familiar with logistic regression, it's an area under the receiver operating curve. It's basically just a ratio of true positives to false negatives. So how often do you classify the results correctly given a certain threshold of probability? So you don't want a 0.5. It really ranges from 0.5 to 1. 0.5 would be like a 50-50 shot that you're classifying correctly, and then 1 would be really, really good. So this was a 0.8, so it's reasonably okay. We accepted everything above a 0.75. So basically, what we have here is a probability of equilibrium loss, so probability of that release code 3, and then you can see there's a positive correlation with barotrauma score, which is no surprise for red snapper. But the real interesting result here is the different descending device types. So you've got the lip grip, that's a little worse than something like a fish elevator, and then even better would be the inverted hook, which I did not expect. I thought that the fish elevator would be one of the better ones, particularly looking at Steve's results with his cage release over the years, but I know it's not the same, but I thought it would offer a sense of protection to the fish. Same with predator interaction. So we talked a little bit about capture depth. We really didn't have that many samples beyond 200 foot. So that's feet at the bottom on the x-axis. Excuse my English units. And then we have, so once again, lip grip performed the worst. You have fish elevator and inverted hook perform the best in these shallower depths. As far as predator interaction, and remember, predator interaction is when a predator would make an aggressive move towards the fish, even if it did not consume it or mouth it. So greater amberjack, so that was red snapper, this is greater amberjack. Same thing, predator interaction. Again, logistic regression with the descender device treatments. So greater amberjack, we weren't really able to use the fish elevator because their body size was so large. So we are only able to use the lip grip and the inverted hook. But you can see there's the inverted hook once again performed better than the lip grip as far as predator interaction. And we think that might be due to the fact that you know, the settings on the sequelizer to release them in kind of the mid-water column. If you're fishing at 100 foot and your release, I think it's in increments of 50 feet. So if you release at 50 foot, you know, that's kind of might be top of the reef or just above the reef, which is where kind of those predators hang out. So if you don't want to set it at 100 because it might hit the ground, and then you pull the snapper back up, so you set it at 50, it pops off at 50, and that's where all the sharks are, and they say yum yum. So there might be a predator interaction kind of result with the way that the sequelizer works versus an inverted hook that's going to send them all the way down to the bottom past some of the predators. And that the two attributes that were chosen through the stepwise regression selection was capture depth and fight time. So predator interaction positively correlated with capture depth, negatively correlated with fight time. So some logistical effectiveness. We talked about angler surveys, just give an overview here. Anglers were more familiar with the lip grip devices. I think they preferred the lip grip so far with the feedback we've received, just kind of a qualitative overview. Because they're so familiar with it. And then, of course, elevators, they take one look at that fish elevator and they're like, no thanks, it's so huge. And then as far as our research team, they also kind of preferred the lip grip. And then the elevator, they really kind of drove home that it works well in theory, but not in practice. So this looks like it's underwater, but that's actually on the surface. So the elevator is hanging over the surface, and that fish had just basically started descending before we could even drop the elevator on top of it. So it only really works if the fish is full on stomach averted, inflated, if you will. and positively buoyant. So overall, only 10% of releases ended up in a negative result across species. That's pretty good. If you basically translate that into discard mortality, which I know is shaky because we're not looking at long term here, then you know, that's pretty good. Especially considering that we were working off Louisiana and the last red snapper Gulf of Mexico CDR. I think the discard mortality estimates ranged from 21 to 41% for the western Gulf of Mexico, so that's far under that. The sending device with the most negative results would have to be this lip grip. However, I don't know how that directly compares to some surface release, and maybe as we continue the project, we'll, you know, test that out. Maybe some vented surface release or something. A fish elevator, it performed consistently outperformed by the inverted hook, which I did not expect, and it's also cumbersome. So the inverted hook kind of performed better for everything but great triggerfish. Great triggerfish only had a 8% negative result on the lip grip device, and we couldn't really use the inverted hook on the great triggerfish because they're so bony around their mouth that you really couldn't get the inverted hook through there to drop it down. So with that, I'll take any questions.
Did you look at any size difference between device types?
Like fish size? Yes, yeah. We did measure fork length. It's just that whenever the stepwise regression, whenever we did the stepwise regression, it didn't choose it based on the lower AIC value. So I know I expected fork length to come out, and we also did fight time, which two things you talked about, right? And neither of them came out, and that we might not have the sample size we need yet for that to kind of come out.
Yeah, it's interesting to see the comparison between the sealator and the descending, the sequelizer. So I know that we've often used the sequelizer. It's kind of the more well-known of the products from sequelizer, but the sealator we've used with a few captains and on some trips that we've taken, and they've really liked that device. Yeah,
That's
and
good.
so it's interesting to see that you guys use that and found some results to kind of support using it and the ease of use with it as well. I'm glad we added that as part of the study.
Yeah.
Yeah, the learning curve is higher for the sealator, but once you get the hang of it, you're like, okay, this is fast and can be used really effectively. But it's that getting over that initial hump of trying to learn it versus the sequelizer, which most fishermen are familiar with the boga grip, so it's something they're used to.
Erik, you said you're using like 3 to 5 pound weights?
Zach, 3.5. Yep.
And then you had a bandit reel they're using the whole time for
Yep.
retrieval and descending?
Is that right? Descending bandit? Yeah, everything's captured on convention, yeah. But then we descended on a bandit.
Yeah, I'm just trying to think across, parallels between all the studies, and obviously right now we're just trying to get messaging out, like what works, what they can actually use and be efficient and get the fish down there. But I think a big variable is going to be, the speed at which it descends, and that's based on the weight size, and the fish size, of course, affects that as well. So I'm just trying to figure out like what's practical, and the weight. I mean, obviously, Amanda, you said in your presentation, or that video said, more is better, but where's your limit? When you have if you're using a rod and reel, 5 pounds is pretty heavy to reel up sometimes, and you just don't want to do that. And Steve, you were using a rope as well, right? When you released it, it looked like you were using like the rope.
Yes, and we had a, microphone please.
I'm sorry.
We had a 5 pound to 10 pound weight on a rope, and we pulled it up with a winch, so.
Yeah, so, so I'm just, yeah, you pulled it up, I mean, it's mainly getting it down, you can, but yeah, pulling it up in a winch is not practical either. I remember we used to use the 5 pound weight in ours, and we had that little electrical spool, because I released all my fish from like an inverted hook for my study, and we had an electrical spool that I got at Home Depot, you know, and used that with a little like 1/4 inch rope, something like that. But anyway, that's just a variable. I was curious how it might affect the results.
Yeah, to your point, Darren, I know Nick's been trying to get this out with the messaging is we're recommending about 1 pound of weight per 5 pounds of fish. And so most fish that people are descending aren't going to be more than 10, 15 pounds. Most of them are undersized. So you need 1 to 2 pounds. I mean, you'll have we send out a 3 pound weight with the descending gear that we send out, which is usually plenty. The instances which are not as common as we'd like, we're catching bigger fish, you can just strap on a little bit more weight. And then we also recommend folks use a high-speed reel, because you don't want to be using a 1-to-1 ratio reeling that thing up. It gets pretty cumbersome. But with those high-speed reels, you can reel them up pretty quickly. Any other questions? All right.
Okay, we are ready for our next presentation, the mitigation of gag release mortality in the Eastern Gulf of Mexico by Dr. Will Patterson. And he's going to be a virtual presentation.
Yeah, so thanks for the opportunity to speak this morning, especially remotely. I was actually supposed to be in Saba this week, but hurricanes here in West Florida have kept me at home to deal with repair issues. First, I'd like to acknowledge the co-authors on this, Sue Lowry Barbieri, who's at FWC and UF, Celia Zimmerman, who is a graduate student here in Fisheries and Aquatic Sciences at UF, Zach Siders, who's a fellow faculty member at UF, and then Maya Taylor and Joe Tarnecki, who work in my lab. Next slide, please. So obviously we're hearing a lot about barotrauma effects on reef fishes, and we see oftentimes these pretty gnarly pictures of distended or everted esophagus, distended anus, exophthalmia, and oftentimes these lead to mortality. However, we also need to consider that there's sublethal effects even when we don't see fish just stranded at the surface because of issues with barotrauma. Next slide, please. In the southeast U.S., there are reef fish fisheries. We have some big concerns, especially in the recreational sector. With discards, we tend to manage our fisheries more as far as it's an open access as far as effort, if not for retention. And because we have mixed fisheries on the reefs themselves, we end up with lots of regulatory discards for various species, either in the Atlantic or in the Gulf. So on the left is Atlantic red snapper, where the estimated number of dead discards is much, much greater than landings. And dead discards alone are driving estimates of overfishing for that stock. The fish that we're going to be talking about, I'll be talking about this morning, is gag. So gag is a protogenous grouper, and in the Gulf of Mexico, we don't have quite the issue that exists for Atlantic red snapper, but in the most recent stock assessment, you can see the dead discards were roughly equal to the estimates of recreational landings. So still, if we can mitigate discard mortality and barotrauma, then we can turn more of those dead discards into actually landed harvest. So that should be a goal for management. Next, please. Gag has a history and makes it susceptible to barotrauma and catch and release mortality. So this is a conceptual model of gag spatial ecology across its lifespan. from Lowry Barbieri's 2020 paper. And the highlighted box on the Florida map is the region where our study takes place. And in the depths from about 20 to 50 meters, we get mostly immature females and just mature females in this region. Those animals go offshore and spawn. Males tend to stay on the 40 fathom curve deeper and where spawning aggregations occur. And the females are thought to move back and forth across the shelf. So most of the fish that are encountered by the recreational fishery, sort of in the mid-shelf region, are actually either immature fish or young mature females. Next, please. So the goals of our objectives of our study were to employ high-resolution three-dimensional acoustic telemetry to estimate the fate, such as survival, mortality, predation, and emigration of gag captured with recreational fishing gear in the eastern Gulf of Mexico, the West Florida Shelf. Secondly, to estimate the effectiveness of center devices to mitigate release mortality. And third, to estimate whether venting gag at the surface enhances post-release survival. Next, please. So our study design, we have acoustic receiver array. Our planned design was to have one large array off of Steenhatchee, Florida, with a three-dimensional telemetry to track reef fish movement. However, I'll talk about in a second, we had to modify this based on the spatial distribution and density of fish in some reconnaissance ROV surveys that we ran ahead of deploying our arrays. Second, to catch, tag, and release gag at the surface, so sample size of 20, at the surface following venting, and at depth with a descent device, and winter as well as summer, so we can look at seasonal effects, so water temperature as well as air-water temperature differential. And then third was to then retrieve the acoustic receivers and estimate gag geoposition, movement, and fate. And I included this figure to the right from some recent work that we've done with gray triggerfish at 30 meters depth in the north central Gulf of Mexico, off of Florida, northwestern Florida. And the top panel shows the estimated change in depth from sequential detections of gag using, gray triggerfish using three-dimensional telemetry. And on the right shows their estimated speed. So these are fish that were caught, released, and descended depth. And then you can see the weeks. So the red on the left is days 1 through 3, and then we have weeks 1 through 7. Week 2 shows up twice. The yellow should be week 3. But you can see in these data that gray triggerfish don't move a lot during the middle of the night. So from midnight till about 8 a.m. Their activity is much greater during the daytime. But these animals that were caught, released, and descended, it took them 3 to 4 weeks for their behavior to sort of plateau. So for their change in depth to plateau, they were moving higher in the water column versus hanging closer to the bottom. And then also their speed. So clear indication that sort of chronic sublethal effects can occur with catch and release. And three-dimensional telemetry is especially useful in examining these types of effects on movement behavior. Next, please. So we did some reconnaissance surveys with a remotely operated vehicle. So a Pro 4, VRA Pro 4 ROV, you can see in the top left. And we just jumped on a boat here at UF and ran offshore Steenhatchee, Florida. Our areas that we surveyed ranged in depth from 15 to 20 meters deep. And they had a series of different artificial reefs. And as we did this work, we were looking for areas where we could deploy a large 80 receiver array in which we could encompass an area of about 15 to 20 square kilometers and examine gag spatial movement as well as release mortality in that area. But we didn't find areas where there were sufficient gag among artificial reefs deployed. These reefs were deployed about 20 years ago, a little longer than that in some cases, by Bill Lindbergh and FWC. They've been very useful in a series of different experiments that Bill and his colleagues have run. And we were able to get the coordinates from Bill to actually do this work. So our farthest array, which Instead of one large array, we had to build 5 16 receiver arrays with 420 meter spacing. And the farthest site was 75 kilometers or about 40 nautical miles from Steenhatchee. So these again, that would be sort of a deep run for most of the recreational fishing boats. You know, Steve Szedlmayer mentioned go fast boats earlier. So some boats will run farther offshore in a day trip, but the predominant winter recreational effort is in this depth zone of these reefs. Next, please. And so on the left, this just shows our setup for the receivers. We have a concrete base that weighs between 80 and 100 pounds. And then we have a PVC pipe that stands 2 meters above the seabed to facilitate detection. Above the Innovacy VR2X receiver, we have 2 meters of line and then a syntactic foam float. And in the bottom machine in the bottom left, you can see the return from that float. That's what really helps us to see the receivers when we're retrieving them. The picture on the right will be a video in a second, but this is in the pool at UF, and it shows actually a lobster trap, but this is the method that we've developed for retrieving the receivers. The ROV is equipped with a mooring hook cradle, and so we fly the ROV up to the receiver base, and we hook it with the mooring hook and then fly the ROV away, and then we can retrieve the base or any other equipment from the seabed with a winch. And so this setup allows us to be very nimble, and we can deploy an array of 80 receivers in a couple of days, and we can actually pick it up in a couple of days. And so, you know, one of the limitations of doing this type of work is actually retrieving the bases, getting your receivers back. Sometimes they're anchored to the seabed. Sometimes folks use very expensive acoustic releases, but this method allows us to do it pretty quickly in a couple of days. So when the slide advances, you'll actually be able to see the ROV fly up and grab the base. So please advance. So when the ROV flies away, the line is left attached to the base, and then we can retrieve it to the surface. Next slide, please. So in winter 2023, we had our first tagging event. And so we deployed our 80 receivers in 5 different arrays a couple of months beforehand, and then we waited on a weather window to be able to go tag fish. So this was accomplished in mid to late March, a little later than we were hoping, but winter weather can be difficult. We used stopwatches to time the fight as well as the time out of water for gag. We inserted a Floy anchor tag into the dorsal pterygophores. And then we also tagged the animals with Vimco VP13 tags, a little smaller than the tags that Steve was mentioning earlier. These tags have nearly the same acoustic output as the tags that Steve mentioned, but in water, their mass is about half of the V16 tags. So it's a little easier on smaller fish. And then the venting tool that you see there is what was used to vent fish at the surface. Next slide, please. So Brendan Rundy, when he was still at NC State, had done some research into different methods that have been utilized to attach external tags. External tagging is required for this type of catch and release study. And so in the bottom right hand is the tag that Aaron Bohoboy had deployed. We've used this for red snapper and for gray triggerfish. Brendan found that tag attachment had 100% retention, but it had a little higher abrasion issues, like Steve had shown with his lab-reared fish. And the spaghetti attachment in the bottom left and the cinch up had similar retention, but less abrasion. So for gag, we used a combination of the cinch up and spaghetti approach. We used the gray caps like you see in the spaghetti, but instead of having a second line where the cinch up was attached to, we just ran the cinch up tag through the actual tag cap and used that to actually attach the tag to the fish. Next, please. This is the total length distributions for the 60 fish that we tagged in winter 2023. And you can see that the vented fish, and we just randomized this, every third fish that was captured was placed into these categories. There were 3 fish that we attempted to descend and they fell off the descender, so those were just treated as surface releases. And then the next fish order was descended. And so the vented fish the mean was slightly smaller, but no significant differences here due to the variances that you see. On the right is our time out of water, and the descended fish, it took us about 40% longer to get them back into water because we had to attach the descender device to, this was a sequelizer, I should have mentioned that earlier, it's a sequelizer descender device. We'd attach it to the lip of the fish, and the venting adds slightly more time than just surface release. The median here in the box plot is 6% longer for vented fish versus surface. But to take measurements and examine whether the stomach was full of gas or not, a qualitative measure, it took us about 90 seconds for surface release and nearly 95 seconds for vented. Next, please. We also tagged some fish at depth to get some positive controls. So this was an approach that Jeff Buckle started using in North Carolina. We thought it sounded pretty smart, so we've been doing it as well with gray triggerfish and now gag. And so these fish were actually angled at depth. I was skeptical this would work given how skittish gag can be, but it actually worked quite well. So divers dove to depth and they hand-lined gag from about 5 meters off the bottom. And then when a fish was hooked, they just swam down and grabbed the fish and measured it and then inserted the tags as we do on the surface. So this provides a positive control to see what a live fish looks like on the bottom. And one of the advantages of this approach is the fish doesn't experience any barotrauma. So it doesn't have to come to the surface and then be put down in a cage or some other approach. Next slide, please. So we had a couple issues in our study. The first was Hurricane Idalia, who is a major storm that came ashore at the end of August in 2023, passing right over top of our gag telemetry arrays off of Steenhatchee. So we weren't able to get out until about a month later to actually surveil the situation. And unlike storms that have passed over top of arrays, when we've had stuff out in the north central Gulf where the bottom is a little sandier or muddier, the harder bottom on the West Florida shelf, our receivers and bases didn't actually sink into the sediment, but instead they often toppled over and sometimes rolled away maybe 10 or 20 meters. They also lost their floats, and the floats are really important to us for being able to find them using a bottom machine. They show up otherwise, but that float really sets off the bottom machine and is useful for finding the receivers. So we had to sort of recalibrate how we were going to get these back. So instead of using the 28-foot Parker that we have here at UF, we had to work with Josh Livingston in Destin, and he and his crew came over and we spent a few days offshore. Sometimes we were able to retrieve the bases with ROV, other times we had to dive on them to get them with lift bags back to the surface. Next, please. So we got our receivers back, all 80 of them, thankfully. We had 823,000 tag detections, and of these, we were only able to actually get geoposition estimates from 13,805 detections. And so from March of 2024 to August of 24, we would expect millions of detections from the 60 fish that we had tagged. So we had a ping rate of every 2 minutes, randomized between 1 minute and 3 minutes. So about 130,000 pings per tag over this time period, times 60 fish, that would be about 7.7 million pings. And given the spacing and detection testing, we would expect about 3.5 million of those to be able to generate geoposition estimates. Nearly all of our geoposition estimates were only heard by 3 receivers. And typically we hear in the north central Gulf of Mexico with a little bit wider spacing than this, we typically get geoposition estimates coming from at least 5 receivers. So the key is to space your receivers in a way where you're going to have a high probability of any ping being heard by at least 3 receivers, so you can triangulate position. However, again, with a little bit wider spacing, 500-meter spacing, we're able to get typically greater than 5 receivers picking up a given ping from red snapper or great sugarfish work we've done there. And so the fact that nearly all of our geoposition estimates only came from 3 receivers meant that there was a confounding factor here. And given the structure of the habitat, so these were all artificial reefs, and you can see the top left, that's what they looked like when they were constructed. And the right and bottom images, you can see what they look like fouled over time, and gag like to hide in these structures. This is likely what caused our low detection rate, is gag were just hunkered down in these holes. And so if we did happen to hear a ping, it was only picked up by 3 receivers and not more than that. So this was a confounding factor in our work. Still, we're able to estimate movement patterns for most fish over the 48-hour acute mortality period, and then up to 2 weeks later, examining chronic mortality over a longer time scale. Next, please. So this is a figure that Celia put together for some work that she's doing with these data. You can see the proportion of geoposition estimates on the y-axis, and then speed estimates along the x-axis. And this just shows a similar pattern to what we saw with great sugarfish, that from the first 12 hours through the first week, you can see the distribution starting to slide to the right and fill out. And then from the second week through the 4th week in the bottom row, you can see fish starting to move around more as well. So some indication that gag are also displaying some chronic effects of catch and release. Next, please. And we see the same thing with the change in depth, not quite as substantial as what we saw in great sugarfish, but still, it takes about 3 weeks instead of 4 weeks for them to plateau in their movement patterns. They don't move as much during the nighttime, similar to great sugarfish, but their movement is increasing during the daytime, and it takes 2 to 3 weeks instead of 3 to 4 weeks for their change in depth, so their movement off bottom. And gag don't move nearly as much off bottom as great sugarfish or red snapper, but still it takes a while for their movement patterns to sort of equilibrate. Next, please. So with the geoposition estimates, you can see the animation on the left that allows us to track fish movement over time. And so this is one fish followed over 3 weeks, and you can see the scale of movement is only 50 meters on the y-axis and 30 meters on the x. The z-axis depth goes from 14 meters on the bottom up to 9 meters for this fish. And from these data, from movement patterns, from depth changes, where the tag is in the system, and Steve showed what predation looks like with sharks moving very rapidly through the system, we can assign potential fates. So fish can be alive, they could have immigrated out of the array, you could have tag loss or failure, discard mortality, or then predation as well. Next, please. So this is a decision tree used for great triggerfish. I'm not going to run through all of this, but you can see it can get quite complicated. And we're not to the point yet with gag where we feel like we have a decision tree that we can rely on for a couple of reasons. One, gag don't move nearly as much as great triggerfish or red snapper. So it's actually a little more difficult, even under optimal conditions, to assign a fate to these fish. There's a little bit of uncertainty. And secondly, because of our low geoposition percentages, we've been working through this, and we're not quite there yet. So I'm not going to share any mortality estimates from winter tagging. But I will say that we have 3 fish that clearly were consumed by predators and then moved rapidly out of the array. But there's some uncertainty about tag loss versus otherwise mortality that we're working through, and hope to have this resolved in the next month or so. Next, please. So we Worked with Charlie. Charlie was very beneficial in talking to the restoration office and Treasury to get a continuation of our project, given the issues that we had with Idalia. And so we actually got a little plus up money because it cost us more to go retrieve the array. Also, we were planning to do summer tagging following winter tagging and only retrieve the array once. So we had to pick it up, clean it, redeploy it. Those were added expenses. And so we redeployed the array in August of 24 to do summer tagging. We weren't able to get out to tag fish until the 24th of September. We were actually supposed to be out on the 23rd, but engine issues with the charter kept us from getting out on the water on the 23rd. And then Hurricane Helene passed over our tagging sites 2 days later on the 26th. So we actually saw this coming, there was a forecast for the storm. We wanted to go out and get at least some fish tagged before our receivers got scattered again. And we thought it would be, problematic given how long this has been delayed and the fact that we had to get extra funds to redeploy once. We thought it might be unlikely for that to occur again. So we went out and got as many fish tagged we could, and we're able to track them for at least 2 days, assuming we can get all our receivers back. Next slide, please. So we had to have alternative plans for retrieval. This is what we used. Josh Livingston's boat. Josh is based out of Panama City, or Destin, excuse me. And both the Dreadnought's a large catamaran that we can get 40 receivers and bases on at a time. And in the center picture, you can see the winch and davit system that we have set up on Josh's boat. And then the receivers on the right were the ones that were retrieved. This was actually after Idalia. So we're going to be working with Josh. We were hoping to be out this week, but a front's come through and delayed us. We're going to work with Josh and his very capable crew to go retrieve our bases. Again, sometimes Joe Tarnecki can fly the ROV down, pick them off the bottom. Other times we got to put divers in the water to dive down and retrieve the bases. So to be determined on that. Next, please. I did want to highlight some of Celia Zimmerman's dissertation research. So she's utilizing these GAG data as well as the Great Triggerfish study that I just mentioned I mentioned a few slides back, and then conducting a meta-analysis of the effect of study design on reef fish discard and mortality rate estimation. So we've heard several different approaches to this question so far today: conventional tagging, telemetry or acoustic tagging, observational studies, surface observations or observation at depth. So we have lots of different designs that have been utilized to examine reef fish discard mortality. And so part of her dissertation, one is to produce empirical estimates of reef fish release mortality using three-dimensional telemetry. And then secondly, a meta-analysis of barotrauma, release mortality, and descender mitigation among a suite of reef fish species. And then third, stock assessment simulations to examine the conservation benefit of widespread usage of descender devices. So Celia is funded by Florida Sea Grant. Zach Siders is her major professor. I'm a committee member, and we're working together on these questions. Next, please. Early information from Celia's results are very interesting. So on the left, you can see the number of studies that have been conducted among various reef fish species in the southeast U.S. So this includes Atlantic and Gulf of Mexico waters. So there's this idea that we knew a lot about barotrauma, and there have been lots of studies done. Most of these have been done on red snapper, and there are many species for which we have little to no data. And what one of her objectives is to examine phylogeny and its effect on barotrauma. And gray triggerfish is a great example of a fish that appears at the surface oftentimes to be very strong and hardy and swim straight down. But Jeff Buckle's work and the work we've done in the Gulf of Mexico shows that gray triggerfish can actually suffer really substantial, but not obvious from an external viewpoint, barotrauma symptoms. There are some interesting results from her meta-analysis to date. Right, obviously, cages have a strong negative effect on discard mortality. That's why Steve uses these as a positive control to get fish to the bottom so they don't die. Winter is even a stronger effect. So cooler waters, less stress, tends to be very beneficial. Unfortunately, most of the recreational effort is focused in the summertime when weather's more predictable. The seas tend to be a little bit lighter. But as far as different approaches, whether we're examining surface release or using conventional marker capture, acoustic telemetry produces higher estimates of discard mortality. So a fair question is whether telemetry is adding a cumulative effect. The tagging process is adding a cumulative effect to mortality. But another thing that we do know about telemetry is that we're able to observe the fish for longer time periods and to follow behaviors so that we can examine sublethal as well as lethal effects over time. Next, please. So I think an ideal extension of this type of research would be to expand across the Gulf with the range of species. So Aaron Boboi's research in Alabama showed a clear significant savings using descender devices, about a 50% savings. Steve's release mortality estimates were similar, although his topped out at about 60% and then down to 30% with the descender using telemetry. And so clearly descenders can be beneficial. And gray triggerfish, descenders really didn't have much of an effect. And that's because fish were suffering internal barotrauma symptoms that regardless of getting them returned to depth or not, they return to depth very effectively themselves. It's just given their anatomy, their insides are just kind of blown apart. We did see much higher mortality rates in summer in the north, off northwest Florida for gray triggerfish, but this is also when we saw a lot more predators in the system, and nearly all of that mortality was due to sharks or dolphins eating gray triggerfish upon release. Next, please. Lastly, just put a plug in again for the very useful tool of simulation using population models to actually estimate conservation benefits of center devices. We're hearing a lot about changing behaviors. I think there's less empirical evidence of how the center devices operate and what their conservation benefit might be than is promoted. And this needs to be addressed with more empirical studies, also with population models to assess the conservation benefits. And some really great papers, I think, in the literature recently from our region. One was part of Aaron Boboi's dissertation research, doing stock assessment simulations with the Gulf Red Snapper assessment to look at the effects of different management strategies, including widespread use of descender devices to affect management. And then Kyle Schertzer's recent paper from the Atlantic that takes a similar approach in that region and also looks at spatial closures as a potential management tool. And so, you know, widespread use of descenders should be encouraged. And but in the end, we need to have an estimate of what impact that's actually having on conservation and management, because in the end, this is a management question and it's going to have management implications. If we use descenders and we get them in the hands of folks and they're actually decreasing release mortality, but we have no way to actually capture that in a modeling framework, then it's going to be for naught. Next, please. So lots of folks to thank that helped out in various aspects of the study. Again, we're very appreciative of Gulf States for the funding and NOAA restoration, and Charlie in particular for administering this project. It's been great to work with, very easy to work with, various captains and technicians and graduate students that have helped in the field. And with that, I'm done.
I have one quick question. You mentioned some fish were falling off the descending device, and the descender time out of water was 40% longer than venting or surface release, I believe. Why do you think that was? Was there a faulty sequelizer, or what do you propose?
Nick, I'm sorry. I had the volume turned down a bit because there was some kind of feedback, and I didn't catch the first part of your question. Could you please repeat it?
Yeah, you said that some fish were falling off the descending devices that were considered surface release, and that descender trials took 40% longer for time out of water. Why do you think that was?
Yeah, so in our data, we've seen that type of performance of descender when we release at depth with descenders. We typically get a 30 to 50% increase in the time out of water. Our time out of water is pretty low, pretty short relative to, I think, what most fish are going to experience on the back deck of a charter boat or a recreational fishing boat. But as far as the descender, so we're adding about 30 seconds to the process, and that's simply, pulling the descending device over, getting it attached to the lower lip of the fish. Depending on the species, like great triggerfish, can be kind of challenging to get into their mouths. With gags, not typically as much of a problem, but it's not unusual to have a descender device pop open as the fish hits the water, and there's sort of the shock of that hitting the water. And we try to lower them in slowly, but sometimes a fish is flopping around and it just flops off the descender device. We actually have seen that across species, not unique to gag. Yeah, so I don't think that's the issue. That those fish were actually removed from the time out of water calculation for either descended fish or for the surface release. So they weren't actually part of that meeting.
Any other questions for Will?
Hey, well, you said your detection efficiency was kind of low at some points. How many fish did you have on a site, a given site?
Yeah, so we had 5 arrays, and these arrays were a little less than 3 square kilometers each. And within the array, at the very center, was an artificial reef. But then away from those artificial reefs, we oftentimes had ledges or small rock piles. And so when we got to the center reef, we fished that first. And the way that we fish these is with fairly light tackle, fluorocarbon line, and single circle hooks below an egg sinker by about 2 meters. So we had long leaders, fairly light, and then braided line above the egg sinker so that we could feel the bite. And then when we got to the sites, we would chunk with herring, so cut herring up and get the fish kind of fired up, and then we would drop down live pinfish. And so we would fish at that site, and so we had grouper candy that we're throwing in the water, and then live pinfish that usually gets them fired up. And so we would catch fish for probably half an hour or so, and then the bite would kind of die down, and then we would move around to the perimeter. So then we would tag fish at natural hard bottom sites that weren't at the edge of the array, because we wanted to be able to detect fish 3-dimensionally. But within that sort of center portion of the array, if there were hard bottom sites there, we would tag them. So the most we ever tagged on a given spot was, I think, 10 fish. But within an array, we sometimes tag 20 fish. The array C, the middle array, we actually didn't tag any fish during the March 23 tagging. But in our summer 24 tagging, we encountered quite a few fish there, so we tagged them. So I don't think it was a tag collision issue, which can affect detection probabilities, because we've tagged many more red snapper and gray triggerfish on a site than we tagged here for gag, without having tag collision being a substantial issue.
Yeah, thanks. Yeah, I still think, 10 fish is reasonable, but I mean, I'm not surprised that you have a lower efficiency of detection and probability with just that many fish. You said you expect like 4 million, I think you said, and you got 800 something thousand. But
Yeah, well, I
that's-
can tell you that, again, using the same tags and similar array spacing in the north central Gulf of Mexico, tagging many more fish, we get an order of magnitude higher numbers of tag detections. So I mean, collisions are part of are always going to be a potential concern in these types of studies, but our detection probabilities should have been much higher than they were, and I think it has more to do with the structure of the sites and gag behavior than collisions.
No, I think you're correct. I think you have the efficiency you need to, make your decisions. But yeah, then the structure's there. If the structure's there and you're losing that three-dimensional space, do you think moving your arrays closer together, or your array, each individual receiver closer together would help results?
It's possible. I mean, that's one thing to test for sure. But I don't. It's not going to decrease it.
Yeah, because
I don't know if it would improve it, but it's not going to go down by doing that.
Yeah, I mean, they weren't moving very far, it seemed like, in some of your examples, so it wouldn't, I guess, hurt. But, all right, thanks.
Yep.
Any last questions before we move on? These projects often come with problems that we don't anticipate, and I think Will's has seen the gamut of problems. So I just wanted to say hats off to you, Will, for keeping on, pressing forward with trying to get to the end of this project. I appreciate it.
Thanks, Charlie. It's been the most challenging study I've done in my career for sure.
All right, thanks, Will.
Okay, we're going to now have a presentation on the Alabama at-sea observer data collection, methods, results, and analysis by John Mareska.
Good morning. Presentation says Marie hit. She had something come up this morning, so I'm the pinch presenter, not to be confused with the results of a pinch hitter. So. I think that went too far. There we go. All right, so the background is we're here on the coast of Alabama, as y'all are well aware of today at this meeting. We've got what we consider the largest artificial reef complex in the world is our claim to fame. We have a pretty extensive state and federal for-hire charter fleet predominantly over here in Baldwin County. Fishing effort has been pointed out in previous presentations, is primarily during the summer months when water temperatures warm up and people get active during their summer vacations. The charter trips are generally targeting reef fish species when those seasons are open, and what we were looking for with this program was opportunity to collect information about discard information of key reef fish species. Pointed at Joe. Maybe. There we go. All right, so our at-sea observer program started early under a NIFWIP project, and it wasn't as successful, but under the Return 'em Right, our at-sea observer program has really flourished. I guess the commercial fishermen begin to see the value of the data, and we're also beginning to compensate them for the ride-along. So the objectives were to get the catch and size composition, discard information, the discard behavior, the release methods, how they were being put back in the water, and data on the survivability, so that release condition when they're put back in the water, and then the management effects, how this information could affect fisheries management. So our methods, we have some training components. We have a detailed manual, which is something that is shared among multiple Gulf states. This isn't just an Alabama project. Florida, Mississippi. We've been doing this together for several years now. Observers obviously get trained on identifying the fish. There's an extensive overview of the training program, which is not just the manual, it's the big fin tablet and electronic measuring board. We equip them with safety equipment in the event something should happen. Unfortunately, nothing has happened. And then the main equipment that we use is the big fin scientific tablet and electronic measuring board. And then we have tagging equipment. That's another component of the program, is to tag a portion of the released fish. Data collection post-process. So with the tablets, we're just able to upload the data. It's QA/QC'd, and then we're also provided that data to the supervisor, and the supervisor will ultimately transmit that data to Gulf States Marine Fisheries Commission. The vessel participation, we get the vessel information. We have a list of eligible vessels, and then the vessel list, which is based on, I believe, the MRIP vessel list. And participating vessels, as I mentioned earlier, receive compensation for each observer trip. And then we have the tagging information, which is also shared with Gulf States under the Return 'em Right program. All right. Moving on. ANSI assignments. So each week, vessels are randomly selected, and then we contact those captains to make sure that the trip will be available and they'd be willing to take staff on. The observers are to arrive early and provide them with the compensation paperwork. And then a brief discussion with the captain and crew about the roles, how many people are going to be on the boat, and they start to collect a lot of the information related to the trip. And so the data collection level, we have those 4 different levels right there. The trip information, which can be compiled at the dock, and then station information, which includes information such as start and end time, particular way they're fishing, whether they're fishing over structures, the number of anglers that are fishing at that particular station, which can vary from station to station, the angler information, which is rig type and hook size, and number of hooks. For most of the charter boats, that remains relatively constant throughout the trip. And then the fish information, which is recorded in the big fin measuring board and tablet system, as you see in the picture in the bottom right. Data collection. All right. We had the opportunity. Let's see. Sorry about this, folks. Yep. So we had the opportunity was made available through Gulf States to continue this Advocacy Observer program. All these were available through a grant to purchase all the supplies necessary to complete the task. Streamlining data process were identified as a priority to improve efficiency by integrating these electronic technologies. The initial year of the ATSI Observer data collection was paper and used a traditional measuring board, so we've definitely increased efficiency by not having to enter all this information once we get back to the dock. And we fully transitioned to the electronic measuring board and tablets. It's a Big Fin Scientific is the board of choice that we're using right now. There is a LinkStream app that's is beneficial in creating the fields. Observations are recorded in real time, and then after the trip is over, all that information is exported to a CSV file. And the tablet is operational in most weather conditions, and we have the board that will handle fish up to 100 centimeters in length, which is beneficial for like king mackerel and greater amberjack. All right, and as Marie would say, that the transitioning of staff, they were able to pick up on this transition of the technology and use it very effectively. Oh. We got a video here, I didn't know. That's how fast we're able to measure tag fish, release it, and record their release disposition. So, all right, so we have 2022 and 2023 data here, so you can see the number of trips we've been able to make each year, the mean length of those trips, the number of fish links. So as we went from paper to tablets, we were able to get more fish links per trip, tag more fish, and the percentage of released fish were tagged went up as well. So the pros and cons of the system. So the pros, it reduces personal time spent post-processing the data, increase the efficiency in the data collection, improves the timeliness of the data transfer. The cons is the time set up to get that hardware set up and working, and the training, and then the cost of the additional equipment, and then basic understanding of the use of the electronic devices and the software programs. All right, tag fish returns. So we were tagging our key species, primarily red snapper, gag, great triggerfish, greater amberjack. The tagging process, as you saw in the video, with a dart tag, and it goes very quickly. And then hopefully we get tag returns through the Marine Resources Division website. And we do have tag rewards for anglers who report those tag fish that were tagged during the Return 'em Right program. So in general, you can see where most of our charter boat activity is south of Baldwin County. You can see where most of those boats have been going and operate their trips. So it looks like we've got the vessel for hire trip. So in the early years, you can see under the NIFWIP, we didn't have a lot of participation in 2017 and 18. It ramped up in 2019. Then funding ran out, and now under Return 'em Right, the level of participation, number of trips has greatly increased. So through the past 2022, 2023, we have over 9,000 fish observed. Most of those are predominantly red snapper. We've measured over 4,000, discarded over 6,000, and then most of those were not legal. I don't know if those are sublegal or just out-of-season discards, because we are monitoring year-round. And then we can see vented versus descended, and you can see that discarded and not vented is the predominant, because most of those fish are probably coming up to the surface when those charter boats hit those spots. Barotrauma. All right, so for the different species, we can see that looks like we have very little catastrophic or severe barotrauma. So most of these fish are in fairly shallow water when they're caught and brought up. And there is the tags and the recaptures by species through 2024. And that's it. If y'all have any questions, I'll be glad to try and answer them.
John, that last slide, I was trying to read it, and you went through pretty quick. I was trying to, that 2,128, is that tag returns?
Those are tags.
Oh,
and
that's
only
how many were
67
tagged?
were recaptured.
60, okay. All right, thank you.
And probably most of those tags were just in the last year or so. So the time between tagging and when we would expect a return's not been tremendous. So we're hoping we'll probably start getting more tags in from those. That's a lot of fish.
John, it sounds like they had pretty successful trials with the electronic measuring board and tablets. In Texas, we've had fairly mixed reviews on that. Were there any significant issues while at sea with durability of that equipment, battery life, that sort of thing? Because that could really be a deal breaker if you're just one person out there trying to do it all.
So they've had success with the 4 to 6 hour trips. The battery life has been fine. Haven't had any issues with the equipment itself. But for a 12-hour trip, they've had to take additional battery packs along to make sure that the tablet and the board and everything run for the duration. One thing that's been noted is that right there, the operculums, where the operculums are hitting the boards, they're tearing up those boards, but you're not measuring fish that are in that range. So, but that's been the only issues that I'm aware of.
Yeah, and I just wanted to add, I mean, obviously props to Marie. She kind of took this on, and despite all of the attempts in the past to use electronic measuring boards and issues, she kind of broke down some of those barriers. She wrote a code in SAS to put the software onto these tablets and be able to collect the data, and we've been able to share that with the states. I know Mississippi's working towards getting some to use for the upcoming season, and they've really been working well. I mean, you put up the slide with the pros and the cons, and one of the cons was the cost, but there's a pro to the con that Return 'em Right's supporting the purchase of that equipment, and so we're buying that for them to use, and I think the benefits of it are obvious with data collection, and then, you know, with some of the most important parts of the program are getting the information about survival back from these fish that are released through different methods, and so reducing that handling time is pretty important to that, especially when we're adding the added handling of collecting the data. And I don't remember exactly how long it is, but Marie said the time, and you saw from the quick video there, that they spend handling those fish with the electronic measuring boards is much less than when they were using paper. And so that's another really important aspect to using these boards. And we'll probably update it tomorrow or later today, I don't remember, with some of the expansion into Texas with the at-sea observer sampling. We're going to be using those boards in Texas as well for that.
Okay, now we're going to move on to the Return 'em Right Outreach and Education by Nick Haddad.
All right, thank y'all for bearing with us today. Honored to be the last presentation holding you before lunch. Thank you to the commission for having us, me here today, and us talking about outreach and education, kind of taking a little bit of a turn from the research and monitoring side of this project. So I'll jump right in. I think we've heard a lot about what Return 'em Right is, but just a reminder, it's a 7-year project funded from Deepwater Horizon oil spill money with 3 core partners: Florida Sea Grant, the Gulf States Marine Fisheries Commission, and NOAA Restoration Center. And we talked a lot about the research and monitoring component this morning. Now we're going to move over to the education and outreach and fish descending device distribution, which is being led by Florida Sea Grant and UF. And again, the goals are to reduce mortality in reef fish resulting from barotrauma and release, improve anglers' experience with release gear, and both of those should in turn improve the overall health of the fishery. So we did a lot of work early on in this project setting up the foundation. So we wanted to build a program that was independently branded, one that was guided by anglers but grounded in science. So that's where Return 'em Right came to be. Return focusing on returning fish to depth, and right emphasizing there's kind of a right and wrong way to do this, not excluding venting and surface release either with this name and logo. Set up all new digital media, website returnemright.org, social media at Return 'em Right on all platforms. built an education module that was a prerequisite to receive the descending gear. We wanted to make sure it was easily accessible to anglers and short and concise. I think as fishery scientists and managers, we could all talk for an hour or two on best release practices, but we wanted it to be more of a need to know basis. Procure the release gear, so we used an open invitation to bid process through the University of Florida and awarded contracts to 3 descending device manufacturers. We actually created a pretty nice little kit of gear that includes a sequelizer pre-rigged to a 3-pound weight and a 3-way swivel. So all anglers have to do is tie it on a spare line or rod and reel, and they're ready to use it. And then also include a backup inverted hook descending device as well. And from there, we just had to launch the program. So we launched officially May 3rd of 2022. So we've been distributing release gear broadly in the southeast or to the Gulf of Mexico for a little over 2 years now. So I did want to highlight the education module a little bit and kind of explain why we chose to do what we did here. We used a software known as Articulate Rise, partially because it translates really well between devices, whether that's a laptop, a cell phone, or an iPad. And we knew that anglers would be taking this training in a variety of places and on a variety of devices. And it lasts about 15 minutes, and there's 3 main components. So there's an eligibility form where anglers self-indicate whether their role in the fishery, whether private recreational, whether state for hire charter, federal for hire charter, or if they're not an offshore angler, just interested in best release practices. We deem them eligible for release gear up front, and it's basically setting expectations there. And then whether they, if they are eligible for gear or if they're not, they can still proceed to the training. The only difference is those that are eligible get a shipping form at the end. And then the meat of the content's a little bit on general best release practices, but mostly barotrauma, venting, and descending. So we do highlight both in the training. Talking a little bit about some of our marketing and outreach principles and core values here. It really starts with developing effective messaging. We want to be honest and authentic to the fishing community. The fishing community will sniff you out very quickly if you don't know what you're talking about or if you're basically lying about 100% survival. We know not all fish are going to survive release, even under the best case scenario. So trying to be honest and also use terminology that anglers can relate to, like giving reef fish a fighting chance. And this little line here that probably no one can read is one of my favorites. Saltwater sportsmen turned our best release practices manual into an editorial. And it says the health of the fishery is every angler's responsibility. Here's how you can do your part. We're doing our best to invest in social media. Social media is a monster that can be very powerful. If used properly, it just takes a lot of time and effort. Utilizing ambassadors and influencers. I don't love the influencer terminology, but using content creators that do have a large following, but also influencers can be a local captain that is well respected. It can be a bait shop owner. That term is pretty loose for how it can be used. Partnering with industry leaders, so whether that's media, saltwater sportsmen, Florida sportsmen, or working with TV shows, podcasts, basically using the same platforms to market and advertise that the tackle companies and other boat manufacturers use. So being present in that space and a diversity of outlets. Producing high quality visuals, so a lot of the pictures you've probably seen through today's presentations came from this program. We have a Flickr account with over 1,100 pictures of barotrauma, reef fish, fishing offshore that are available for the public to use. We just ask that they credit return them right. And for 6 to 8 years, I think everyone knew there was one picture of a red snapper on the sequelizer under a boat that was used for every barotrauma presentation for a long time. So it's nice to have some fresh footage, and really high quality imagery can capture your attention. And then from there, it's an introduction to tell a story about why this is important. And really focusing on building a community. We don't want this to be a program where anglers get their gear and they're gone and we never hear from them again. We want to regularly interact with them and kind of focus on creating a culture change where fish floating off behind the boat is no longer accepted, and kind of building that culture up where anglers can eventually hold themselves accountable for making sure that people aren't poorly releasing fish offshore. So just a couple examples. We write a lot of editorials for fishing magazines. This is one from Texas Saltwater Fishing Magazine this year, and we've also published probably 7 or 8 in other outlets, Florida Sportsman, Saltwater Sportsman, Texas Saltwater, and a couple other ones over the last couple years. Bill Dance Saltwater, so local legend from Tennessee, bass fisherman mostly, but he has a saltwater fishing show, featured the program on 2 of his episodes this year. Chasing the Sun TV in Panama City just released an episode on the program, then Return 'em Right on Discovery Channel, and also Waypoint TV, so another episode of Saltwater Experience on the program being released this year. So doing our best to get on some powerful outlets to send this message out to the angling community. And an example of how this can be effective for transitioning from, advertising to actual education module completions. About a month ago, we filmed this video with a YouTube content creator, Life by the Bow, focusing on barotrauma venting and descending. In 1 month, it has 926,000 views. And you can see since then, we've had 2,762 education module completions, and 1,844 came from YouTube. This is Google Analytics here, so you can track these links separately with UTM codes. So 1,500 people clicked on this link that's in the description to the video, and obviously a lot of other people searched it just through search engine and organically as well. So it can be extremely powerful. Within a few days of this video being released on YouTube, we had over 1,000 education module completions. So all of that has led to over 40,000 training completions in just over 2 years. This is as of October 1st, so we're probably at 40,000 gear distributions now already as well. You can see a pretty broad spread across the Southeast. And what's really cool is the #1 way people hear about the program is from each other, 29%, which tells us they're having a positive experience with the program. And I did want to highlight, we have kind of an informational dashboard we use to track education module completions and track the sources of information. So this is just showing you, this is completions by day over the last couple of years. And then you can see right here, 38.2 thousand are private recreational anglers, 555 federal for hire, and 693 state for hire. And then if you want the state breakdown in the bottom left here, Florida 30,221, Texas 3,550, Alabama 2,900, Louisiana 2,000, and Mississippi 762. So that's the breakdown by state. And then also just wanted to again kind of highlight what you can do with this dashboard. So if we highlight, you see this big spike here in completions. This was the day that YouTube video launched, and we can highlight this section of the data, and then it basically just shoots out the sources of information based on that time frame only, and also breaks it down by state. So we can see near real time where people are coming from each day based on state and their source of information. So you can see over here, another angler was the highest normally across all time, but for this section, YouTube had 1,560 during this selected time frame. And you could select up to like 1 day, 2 days, or a month, whatever you want there. So something new that we haven't reported on much, we do send follow-up surveys to anglers after they've had the gear for 6 months to ask them if they've used the gear, if they like the package, why they're not using it. 93% were extremely satisfied with the package of gear, which is great. And 83% prefer a descending device while 14% prefer venting. So 71% preferred the sequelizer and 12% preferred the sealator. So kind of similar to Erik Lang's presentation, a higher preference for that sequelizer. It's a little bit easier to use for beginning people just getting into descending. The learning curve's a little higher for the sealator, but there are some advantages. You can send it all the way down to the bottom, whether you're in 30 feet and get hogfish that experience barotrauma shallow, or you're in 500 feet. As long as you have enough line, you can send it down as deep as you want. 94% reported having no issues with the devices, which is great. The most common issue is anglers having trouble setting the depth on the sequelizer, so it can be a little tricky. The sequelizer also used to have a sticker on their devices that kind of showed how to set the depth, and they've switched over to a molded body instead of having to manually put a sticker on every time, and so that little sticker's gone, and I think that might be causing some problems for people figuring out how to actually set that depth. And then the second most commonly reported problem was not enough weight or too much weight. So too much work to actually reel that in every time, or they were catching bigger fish and the 3 pound weight provided wasn't enough to actually descend that fish. And I thought this was pretty cool that we asked if people were likely to buy them on their own. And 52% were extremely likely to, and almost a quarter had already purchased them on their own. So getting them for free is great, but it seems like people are interested in paying for them as well. Only 1% were extremely unlikely to purchase one on their own. And you can kind of see this is private recreational anglers, some before, after. Before the training, most people, well, almost never anyone used descending devices. That shot up to almost often, between sometimes and often, and in the next 6 months, planning to use them often. Venting kind of decreased a little, but still some use. I encourage everyone to have a venting tool and a descending device on board offshore, because different scenarios might call for different types of release mechanisms. So I just included this slide just after this comment earlier. We try to adapt the program to the needs of the fishing community as much as possible. So we asked what size weight they prefer. Most still prefer the 3 pound weight. 34% prefer a 2 pound. And then in other, it's just split like evenly, like half want more and half want less. So unfortunately, we can't make everyone happy and meet the needs of every fisherman out there, but we can do more for education and outreach, teaching them how to switch weights easier. We used to have a loop knot on there so they could loop the weight off, attach bank sinkers, or switch to a heavier, lighter weight. We actually switched to a dual locking snap, or swivel basically, so they could just pop a stick weight open and switch with a smaller one. Gear use survey. So I know depredation's also on everyone's mind right now. So nearly 80% of anglers reported losing fish on the way up. A little less than 10% reported losing it on the way down. About the same for venting and putting back in the water, and then a little less for non-vented surface release. Again, there's going to be a lot of predation missed by any of this stuff. If non-vented surface release and vented surface release, you're not going to see what happens beyond 10, 20 feet down. And a lot of the times, if you're in 100 to 200 feet, you're missing 80 to 90% of what's happening. So a lot of predation can still occur. And in descending, you'll see a lot of people, some people might be misinterpreting depredation. And then also, it might be happening and they might not know it, so it might balance out. But only 31 out of that previous 1,080 actually lost their device. So that question, or a lot of anglers are saying they're going to lose every device to sharks. 2.9% of anglers, that 2.8, 2.9 reported losing devices that we have provided. And this is some correspondence with someone that reached out to us. They basically said that they lost their device was getting hit by a shark almost every time. Not sure they were sharks, but on the way down, the conventional reel spool started spinning 3 times my drop rate. We were descending a 24-inch red grouper. So that device was working exactly as it should. Once the fish pops off the device, and now you have a 3-pound weight basically in free spool, and you're not pulling down a red grouper anymore, the device is going to speed up significantly. So he had the device set to 50 feet. It was fishing in 150. As soon as it hit 50, the fish is popping off, and now that spool is spinning 3 to 4 times as fast. So that was actually it working exactly as it was supposed to, but he thought it was a shark hitting it every time. Then a couple other things. So 2 people reached out to us and said, they lost their rig to a shark, and I always ask, how many times did you get to use it? This person said they released well over 200 fish with no issues. You're doing a great thing with your project, saving unnecessary fish loss. And then another person said that they lost their gear to a shark, and he said, I've been using it almost a year. I've been grown quite fond of it. They both work great. Not sure how we've done without them all these years. So it seems that people, even though some have lost their gear to sharks, are still having a really positive experience with the gear and the program. And one of my big concerns here is, or one of the biggest things I've noticed, is once people actually give them a chance, they actually end up realizing that they're not that bad. They actually work, and it's almost easier than venting, than people having to come off their spot lock or anchor to circle back and get a fish that floated off after venting or surface released. Let's see. Okay, why is this not working now? Joe, any ideas here? Oh, okay, there we go. So, also, someone mentioned the video earlier. This was a trip with Steve of what happens on a surface release fish at times. So you could see it go down and swim down strong. So kicking down pretty good. But there's still a little bit of gas in that stomach or that body cavity there, and once it gets around 20 feet down, 30 feet down, it turns on its side, starts flipping sideways, and that makes it pretty easy snack for a shark. So that's something you probably would never see if you didn't have a camera in the water. And that's another issue with sometimes saying, just get them in the water as quick as possible. They're swimming down, it looks good, but then they stall out because they're tired from the fight. So moving forward, a couple kind of things we're working on. We did fully convert our training to Spanish. All the forms and the training are now available in Spanish. So we want to continue to promote that. We've only had around 230 completions in Spanish. I guess that's a pretty good start, but I think we can really focus on marketing that Spanish version in certain areas with higher demographics of people that speak Spanish. We try to revise the education module every year based on angler feedback. So we've had over 30,000 surveys completed, the voluntary one after the education module. So we're always looking at those comments, seeing what issues people are having, and doing our best to revise the training. For marketing and outreach, building an ambassador program, we have so many people that reach out and say, how can we help? Can we buy shirts? Can we distribute print materials? So trying to develop a structure, a formal ambassador program, we can actually mobilize some of these participants to help support in their local areas. And then incorporating return them right into tournaments is a big one for me. I just think about some of these rodeos where the winning red snapper's 26, 27 pounds, and how many 24, 23-pound snapper are released to try to catch that winner. When you're talking about culling, tournaments are going to be the highest ones where money's on the line to catch the biggest fish. And I've had several friends in the St. Pete area talk about tournaments they've fished recently with charter captains that have let big gags float off because they tried venting them, didn't have a descending device on the boat, and just tried multiple times and had to watch them float off. So I think there's a huge space for descending devices. I don't want to say required, but some kind of incentive to use them in tournaments when people are releasing a lot of fish, the biggest fish, and also the most avid anglers. So we're hitting on some of the most important things there, all in one space. And then lastly, some scaling and expansion. So our original goal, I think, was around 40 to 50,000 gear distributions with our funding. We reached that very quickly, so we're working on some supplemental awards to get some money for more gear so we don't have to put a pause on that distribution. And with that scaling, we'll probably look for more support in the western Gulf of Mexico. I'm located in Tarpon Springs, so I can travel from Key West to Alabama pretty easily. It's not that easy for me to get over to Texas and Louisiana quite as quickly to go to events in person. And a lot of the times, actually convincing anglers that this is worth it and worth trying, you have to be in person. You can only do so much online in 15 minutes. So we'll be looking for some more support in the Western Gulf for that. And then lastly, the Open Ocean Restoration Plan 4 expansion, Jamie Reinhardt will be talking about just after lunch. And I know there's a project, I believe there's some project ideas to potentially expand return them right to the South Atlantic and maybe even other species in the future. And with that said, I think that's it. Obviously, a huge thank you to everyone that's involved in this project. We couldn't have reached 40,000 anglers in a little over 2 years without the support of all the state agencies, all the sea grants, the commission, NOAA, UF. It's really been a huge collaborative event in order to reach this many people in the short amount of time. And with that, I'll take any questions.
Thanks, Nick, but I think this may be a question a little bit more for Charlie.
So I know the program has funded all these studies, and the first one had something in it that basically there's some instances where possibly just handling those fish efficiently and getting them back in the water is the best case scenario. Probably more than half the time in certain states' cases. I'm not going to speak for the entire Gulf. So is that, I know we're trying to get people to use these different gears to get these fish down, and we're still kind of in the exploratory stage, but are we going to transition the message slightly to certain instances, maybe more than half the time, in my opinion? It's better just to handle those fish efficiently and get them back in the water as quickly as possible. I mean, is that something, once you tally all these results and we get all these things, I mean, to shift the message some, or are we just taking a hard line on the devices?
Yeah, that's a good question, and I think maybe that's not. I guess that doesn't stand out as at the forefront of our messaging with return and right, but that is one of the pivotal points in best handling practices, and we've highlighted that in some of our messaging in the best release handling practices manual that we published. It that's one of the key takeaways from that workshop that we did. It included a lot of you. So I get that probably doesn't stand out in a lot of our messaging, but you got to think about one of the things that we're trying to overcome here is people know about venting. They know about handling, how to handle a fish for the most part. One of the things we saw with the first survey that we did, there's a huge gap in knowledge of even knowing about descending devices, and so we're trying to hang on to that part of the messaging a little bit, so that we can close that gap, because you recognize that if they don't even know about it as an option, then they're never going to use it, and so it's kind of it adds another tool to the toolbox and what they can do. And so we've been putting a lot of emphasis on descending devices, and it's more so to close that gap. But yeah, we are also talking about venting and reducing handling time. And I think a lot of that stuff is in the training that we do. It's just a little quick 15-minute training. There's a venting demo in there that asks people to click on the fish on where you would vent it and things like that. So there's a lot of different points that we've got to try and make, and we're putting a lot of emphasis on the descending devices to close that gap, but we are trying to hit all of those key points.
Well, this was for Nick. I saw you had some comments on there from the fishermen that are using the devices, and I'm just wondering, were there any? I'm sure you got several comments, but were there any saying we use the device, but we feel like we could have done this and things would have been better, or we could have just released the fish, or we could have used better practices? I mean, we may have only been in 80 to 90, possibly 100 foot of water. They were just, I guess what I'm getting at is the overuse of the device sometimes when it's not necessary. So then it puts more of a burden on the fishermen, and as you said, they have to believe in it. They're not going to use it if they don't believe in it. So they have to believe in it, and they have to only use it when it's absolutely necessary, from my experience. But is there a way, or did they comment on, possibly we shouldn't be using this in these circumstances? Did you get any kind of feedback with that?
Yeah, everything you can imagine. That's why you can't just promote one simple message, because we have people that use them purposely in front of sharks, and we have people that purposely don't use them in front of sharks. We have people that email us and say, I use this every time dolphins are on the surface, and then there's other people that say, I'm not going to use them when dolphins are on the surface. I'm going to try to shoot them down quickly, get them away. We have people that use them every fish, and we have people that use them for only bigger fish, or that are a little more tired from the fight. So it's really up to the angler. I mean, the burden, the responsibility is on the angler. So it's up to them to decide either way. There's probably 100 different situations out there that they just have to know and, be intuitive about, learn as they go, and see what works for them. Sometimes surface release is fine. We just showed a video that they look fine. They go down, they can get eaten too. I can't tell you how many vented fish probably get eaten and people never see it or never know about it. So there's just so much, and that's why I always encourage everyone to work quickly. Number one, no matter what you're doing, whether you're surface releasing fish, venting, or descending, time is of the essence. Always have a venting tool and always have a descending device. Have it all on board. Do what you think works best in whatever situation. The key is to just stop letting fish float off and die and just give them their best chance, whether that's whatever method that is.
Yeah, and I'll add a little bit to that. Your question about, if people are not using them as intended or shallower water. So with a lot of the monitoring data that we're collecting, we're able to see if folks are using descending devices in 30 feet of water. And then, we would recognize obviously that that's not probably a situation where you would likely be using a descending device. And so if we start noticing things like that, where there's potential misuse, then we intend to, and we kind of have part of our plans already, is the feedback between the data and monitoring and the messaging that Nick's doing. We meet every week and we come up with plans and we feed the information to him. And if we need to adapt any of our messaging, we are able to do that based on kind of what we're seeing. And that's kind of the feedback loop that we're talking about. He's talking with the anglers, we're getting feedback from all parts of the program, from the data science that we're collecting, the managers, the anglers, and so that all goes into the messaging at the end of the day so that we can kind of keep up with the changes and things that we're seeing.
As a fisherman myself, I was a little skeptical about working on this project myself and what it's going to look like to the angling community. But I can tell you, we probably have several thousand free responses for suggestions for improvement, why they participated, everything. I would say 98% are positive, and the number one message we probably get is that, thank you for this, I've been venting wrong my whole life and it never seemed to work. So the everyday angler, the average angler only goes out a handful of times a year. They're not experienced, they're not on the water every day. And between venting tools breaking, being offshore and rocking boats, not venting in the right spot, people would just vent fish, they'd still float off and die, and then that was their issue. And then they thought that's all they could do at that point. They did their best. So I would say out of all of our comments, that's the one we received the most, is that people were poorly venting and it wasn't working for them, and that's why they enjoyed the descending device.
Specifically with the descending devices, what has been the feedback from the for-hire community?
The headboat fleets, obviously a challenge to get them to use them. We did have a message recently. Someone gave a shout out to one of the long range boats that fishes Pulley Ridge, as it said, shout out to them for having 2 descending devices on the back of the boat ready if anglers wanted to use them. Charter captains are mixed. It's taken me a couple trips with people to the point where now they actually start using them because they have them on electric reels and they just have them in the corner out of the way. So a lot of them have adopted them, or at least have them on board. Most of them don't use them for every fish, and that's where it's up to them to decide when they want to use them. But a lot of them do have them on board. A lot of them use them selectively for larger fish or certain fish, or depending on what kind of fishing. If they're on a red snapper bite with 6 fish coming up at a time, they're going to use a venting tool. They're not going to have the descending device. But again, there's going to be a need for it every time on a boat at some point if you fish a lot offshore, and that's really one of the key things, just to have it, know how to use it, and be ready if you need to. But yeah, the charter captains is still a little mixed. One thing that I struggle with is that there's no secret spots anymore. With Seymour maps, strike lines, all the topography available, there's no more secret spots. So if I'm a charter captain, I would want to be promoting this so that all the other people fishing my spot aren't wasting fish that I could be catching myself. So that's something that I have to do a better job of communicating to them. It's like, I don't care if you use this for every fish or not. know what it is, have it on your boat, and encourage other people, the weekend warriors that might come to your spot once or twice a year, to not have a string of fish floating off that you could have caught otherwise. So there's no secret spots. Like Steve said, he's fishing further offshore on the edges, and still 5 charter captains are reporting back in that like deeper water. So yeah, whether whether it's selfishly for keeping more fish or preventing other people from killing fish incidentally at your spot, I think there's a need to promote it to everyone, whether you use it every time or not.
And I meant to mention this kind of towards the end of John's presentation with the at-sea observer data that we're collecting, but we're building a database right now to warehouse all of the data from that y'all are collecting in Alabama, Florida, and eventually we'll have Texas and Louisiana data in. And all of these questions that you're asking are great, and you will be able to pull that stuff out of the reports in the data that will be accessible to you guys. Just give you your own login. You can pull in and look at information about the sending device use, depth. You can sort it all, filter it. I noticed at the very beginning of the project, this is the first year, and we hadn't really done a whole lot of outreach and education about descending devices, but even in the first year data set, there was this cohort of anglers in Florida that was descending red grouper only. And so you could see there were several trips where like 10 or 15 red grouper were descended in those first few years, or that first year of data. And I haven't seen the second. We're about to finish up the third year now, so I'm kind of curious to see if more folks are using them, just kind of how things are changing. But yeah.
So my question is, I guess with the increase in the use of these devices, is there going to be any efforts to see what the potential effects it has on the population densities of some of these fisheries?
That's kind of what Will mentioned there, and I'm sure there will be a lot more work to be done, not in the scope of this current award from like a management perspective. This is a restoration project, so it's not really focusing on that management side. Obviously, we're collecting a lot of data that can be useful for management, so I'm sure that will be part of it at some point in the future, but not under the current scope of this 7-year project. Also, one more thing from a technology side and advances with spot lock trolling motors, efficient outboards, strike lines, Seymour maps, advanced sonar, bottom facing, side facing, forward facing, advanced radar. The technology list goes on. Electric reels that are under $800 now that everyone can have on their boats. I don't see any reduction, or I don't see it. I don't know how we'll ever get to a point where we're, we saved a couple fish from circle hooks or from descending devices, let's get more days. I mean, that's not up to me to decide, but you have to think about those technology changes and how efficient we're being, and how it's not 80% of the fish being caught by 20% of the fishermen anymore.
Yeah, and I'll take the opportunity to add a little bit to that question. It's a good question, and it's something that I've noticed with a lot of the conversations, kind of going back to how this is used in the science, which is a great question. This is a restoration project, and so the information that we're collecting is to help us monitor the restoration and whether it's being successful or we're having the intended effects of what we set out to do. Now, that being said, we understand the importance of the data being used in science, and it is available. We're planning right now to meet with the Science and Statistical Committee with the council in February at the next meeting. We're going to have a whole day to talk about some of the data that we've collected through these projects that you just heard about, and that we're collecting through the at-sea observer program and through some of the dockside validation surveys. And so there is the possibility to use this in the science and management decisions, and we're trying to kind of actively right now engage and figure out how exactly that'll happen.
Hey, Charlie, this is Will. I have my hand up, but I'm not sure you can see it because I'm online.
Oh, yeah, go ahead, Will. I didn't see it.
Hey, Nick, would you mind, excuse me, would you mind scrolling up to the slide that you had toward the beginning that had the objectives of this? Thank you. Yeah, so the number one goal of this whole project is to reduce mortality in reef fish resulting from barotrauma and release. Right? So if I had a project that was, you know, tens of millions of dollars, or even $100,000, if I pitch that idea and I say this is the objective, then I'm probably not going to get funded unless I detail methods that allow me to estimate or test whether that objective has been met. So what level of reduction would this restoration project need to produce for the objective to be met, right? So it's just kind of this vague reduction, but still, it seems to me that whatever bucket of money this is coming from, whether it's restoration or mitigation or what have you, that if your objective is to reduce, then you need to measure how much reduction has occurred. And, probably folks in the room are sick of hearing me make these statements. But I just, I think that to fully capitalize on the tremendous investment and from all appearances, the tremendous shift that this investment has brought in angler attitudes toward these devices, for those anglers to be rewarded sufficiently for their changed behaviors, you got to quantify what the effect has been and the implications of that for the populations. You're not reducing mortality out of altruism, right? You're reducing it to improve these populations to allow more of the total harvest, the total kill, not harvest, but the total number of dead fish to go in the bucket of landed harvest versus dead discards. And so it seems to me that for a very small amount of funding in the scope of this giant project that's tens of millions of dollars, that you could actually address that in a very effective quantitative way. And there are two examples that I cited in my talk that show how that might be done. There are other ways to do it. I mean, Kyle Schertzer's recent paper in the Atlantic, I would encourage everybody to go read. It's a phenomenal piece of work because not only does it examine this idea of what level of bycatch reduction might be effective and what are the implications for the population, therefore management of Atlantic red snapper, it places it in the context of other management types of measures that would have, what's the scope of benefit of this versus other things, right? Because there's an opportunity cost potentially of spending whatever it is, $30–40 million on descending and promoting descending and putting descending devices in the hands of all anglers versus utilizing that for some other potential project. So I just think that it would be smart of everybody involved to get away from this idea of this is a restoration project, therefore we can't go into population modeling and actually estimate what impact our restoration is having. It seems to me that it's imperative.
Well, I did want to just bring up something that with this IRA funding, we're doing everything we can to get a better grasp of discards. So it seems like, we don't have the best grasp on the number of discards, when people are fishing, where they're fishing, how they're acting as of now. So we have at least some ways of knowing changes in behavior, whether that's adding questions on venting and descending to the Southeast Region Headboat Survey, the state validation surveys, using the initial surveys from the Gulf States Marine Fisheries Commissions on attitudes and perceptions and seeing changes in behavior. And if we can relate changes in behavior to changes in survival rates, that's at least a start to that process. But I think until we get a better grasp on discards altogether, it's going to be hard to directly quantify that. Yes, we can model that, and you mentioned some of Celia's work that is partially funded from Return 'em Right. So some of what she's looking at is doing that as well.
All right. Well, we're a little bit over time, so I think I appreciate all the questions from everybody. Good conversation. Thank you to the Powerhouse team of scientists and resource managers to present on the work that you've been doing. I think that moves us into the lunch break.